Why do so many companies struggle with IT and software development? Why is it so hard to attract great talent and service providers? And what separates the fast-moving tech pioneers from the stragglers that always keep lagging behind? My name is Sushil, and together with Balu and Oliver, we are the founders of Talentship. At Talentship, we have consolidated our 25-year experience. We've founded, built and sold 5 global tech companies with headcounts of up to 400 people. We have built excellent IT teams across 11 countries. We develop products that are now being used by more than 25% of the Fortune 500. And we have run several IT consulting and software development companies on 3 continents. Our biggest challenge has always been building a strong product and IT team. Up until 3 years ago, when we finally got it right and developed a unique method that put an end to our challenge. Ever since, it's been like a dream come true. We've got the top 5% talent working on our teams. We fill open positions like this. Quality and speed of output are on all-time highs, and we're delivering complex products like clockwork. And our cost is even 50% lower than before. No more struggles with IT. We know it sounds crazy, but it's the truth.
And here's how we can help you succeed. Firstly, based on our eye-opening experience in India 3 years ago, we have developed our own data-driven method of finding premium engineers quickly and at scale. This way, we are able to provide you with virtual in-house teams that have exactly the skill set you need. Their output is world-class, meeting and exceeding European standards. Secondly, we only employ very senior IT experts to manage the teams, both in India and in Europe. Our managers have been in your shoes. They bring your virtual in-house team to high performance, and this is where the magic happens. Thirdly, we follow our proven playbook to create a strong in-house team culture and tear down language, intercultural, and communication barriers. We know how to make our teams yours, fully embedded in your culture and processes.
State-of-the-art product development, artificial intelligence, machine learning, sophisticated data engineering, cloud migrations, or 24/7 DevOps. Whatever your challenge, with Talentship you will have top talent working for you quickly. Over the last 3 years, we have successfully demonstrated the power of our Talentship method in more than 100 projects. We have surpassed the results of traditional in-house, freelance, and outsourcing models by far. We are so confident, we even back it up with a guarantee for you. So, if you would really like to address your IT challenges, and if you like the idea of working with an experienced partner who's been in your situation many times over, please book an assessment call with us now.
AI is changing the game for app development. Firebase is here to help. We offer a platform designed to support you throughout your app and business's journey, so you can rapidly build, release, monitor, and optimize apps with Google's latest AI technology. Easily build AI-powered experiences into your apps with speed and safety. Then, launch, monitor, and iterate with AI tools that help you optimize your app's quality and experience. All with assistance provided by Gemini, Google's largest and most capable AI model, helping you to work faster and smarter. Firebase helps you run your app with confidence, deliver the best experience for your users, and get to market quickly and securely, doing what you love. Make your app the best it can be with Firebase. AI is changing the game for app development. Firebase is here to help. We offer a platform designed to support you throughout your app and business's journey, so you can rapidly build, release, monitor, and optimize apps with Google's latest AI technology. Easily build AI-powered experiences into your apps with speed and safety. Then, launch, monitor, and iterate with AI tools that help you optimize your app's quality and experience. All with assistance provided by Gemini, Google's largest and most capable AI model, helping you to work faster and smarter. Firebase helps you run your app with confidence, deliver the best experience for your users, and get to market quickly and securely, doing what you love. Make your app the best it can be with Firebase. AI is changing the game for app development. Firebase is here to help. We offer a platform designed to support you throughout your app and business's journey, so you can rapidly build, release, monitor, and optimize apps with Google's latest AI technology. Easily build AI-powered experiences into your apps with speed and safety. Then, launch, monitor, and iterate with AI tools that help you optimize your app's quality and experience. All with assistance provided by Gemini, Google's largest and most capable AI model, helping you to work faster and smarter. Firebase helps you run your app with confidence, deliver the best experience for your users, and get to market quickly and securely, doing what you love. Make your app the best it can be with Firebase. AI is changing the game for app development. Firebase is here to help. We offer a platform designed to support you throughout your app and business's journey, so you can rapidly build, release, monitor, and optimize apps with Google's latest AI technology. Easily build AI-powered experiences into your apps with speed and safety. Then, launch, monitor, and iterate with AI tools that help you optimize your app's quality and experience. All with assistance provided by Gemini, Google's largest and most capable AI model, helping you to work faster and smarter. Firebase helps you run your app with confidence, deliver the best experience for your users, and get to market quickly and securely, doing what you love. Make your app the best it can be with Firebase.
Hello, hello everyone. Good morning, good evening, and good afternoon to everyone who is joining us from any part of the world. Welcome to React India 2025. I am Rajat and I'll be your host today. Can you believe this is already the sixth edition of React India? It was 4 years ago when I first MC'd React India, and I still feel like it was yesterday, and I'm just as nervous as I was that day. So if you feel like, I'm stammering or if I'm feeling nervous, well, I am nervous, so that's probably why. But yeah, it's been 6 years, and we have grown so much. We have created an amazing global community, that knows us from all around the globe. Uh, so let's begin with today's remote day, which I like to think of as an appetizer to the main event that is going to happen at the end of this month in Goa. So today is just because it's an appetizer doesn't mean it's any less, right? So this day is packed with a lot of insightful talks from the brightest minds in front end development. We have got talks that touch everything that's happening in today in the world of React and in the world of web development or any kind of development where React is, and well, React is everywhere, right? So we have got talks that are that are about AI-driven workflows. They're about performance optimizations and about amazing innovations that talk about accessibility, state management, and a lot more. Before we start, I would like to give a huge thanks to all our sponsors, starting with our platinum sponsor, AWS. AWS, well, what can I say? Everyone knows about AWS. We are really thankful to them for powering this event and React India. You might have noticed there is a QR code that just appeared on your screen. If you please scan it, and it will take you to AWS Builder Community, where you can join their workspace and connect with fellow developers, hobbyists, and amazing experts, and get to know a lot about AWS and how it can help you in your React development. We have got a long day ahead of us, and I want to thank you as the audience as well for joining us on a work day, a Wednesday that too, Aham day. So wherever you are, whether you are at your home workspace, or you're in a co-working space, or if you're in a cafe, and whatever excuse that you're given to your managers, to skip work and join us, we are really grateful and thankful for that. Please stick around, and we hope you'll learn a lot. That's all I'll say. Let's begin with our first talk of the day. We have got Yangshin Tay with us all the way from Singapore. Yangshin is here to talk about Groundpack, a new software or tool that he has created as the co-founder of Greatfrontend. Yangshin is a seasoned front-end engineer, and he has worked on many amazing things. He has been part of the Meta team, and he has created a lot of different apps and web pages as well. I don't know. Have you used Docusaurus? Yangshin created that. So, Yangshin, how are you?
Hey, I'm doing good.
Yeah.
Thanks for that.
Well, so I'll let you take over, Yangshin, and all the best. And thank you for joining us once again.
Thank you. Is my screen visible? Okay, I'll start. Hey everyone. Thanks Ray India for having me. So today I'll be speaking about Groundpack, which is a library that we built at Greatfrontend to power our in-browser coding experience. So Groundpack is a modern, lightweight, ESM-based coding environment that you can use within a browser without any installation. So a little bit about me. I spent five over years at Meta, and some of the highlights at Meta was that I created Docusaurus V2, which is most of what you're using now on Docusaurus, which Docusaurus is used by sites like React Native, Jest, and I also led the development of Meta.com. So in 2023, I left Meta to start Greatfrontend, which is a platform for front-end engineers to upskill themselves. And my interests are open source, design systems, front-end tooling, and more recently, I like to post on LinkedIn. So what is Greatfrontend? So it's a platform for front engineers to level up their skills. So you can work on coding challenges within a browser. You don't have to install anything. Just head to greatfrontend.com, find a question, start practicing there. So there are different kinds of questions. There are like JavaScript functions. It can be UI in different JavaScript frameworks, and also like quizzes and system design content. So there's also a projects product where you can develop small challenges given some design, framework designs, APIs, and which are useful for building up your portfolio. So here's a demonstration of Greatfrontend's coding workspace. So this is you see this question on implementing a promise.all polyfill. Yeah, so you can run the code within the browser, and it'll tell you if your implementation is correct or not. Yeah, so this coding workspace, in the first version of it, when we built in 2023, we were using Code Sandbox Sandpack library, which is an in-browser coding environment that is also used by Code Sandbox. If you use react.dev, which I'm sure you have, the embedded coding examples there are using Code Sandbox Sandpack library. So how Sandpack works is that all the transpilation and code execution takes place within the browser using an iframe. Yeah, so we use that on Greatfrontend for executing your code and running tests. So when we first built the Greatfrontend, the layout for the coding workspace is fixed. So for JavaScript question, you have two layouts. What you saw just now, description on the left, edit on the right. And for UI questions, there's additional preview on the right side. So then there are 3 columns. So this layout has a problem where doesn't meet every developer's needs. So we are developers, we are picky, we like to customize a lot of stuff, and there's no one size fits all or a single best layout that is for a specific user. So this fixed layout does not scale well when we have more features we want to add, like community discussions, we want to add AI tutor. Yeah, so the layout, a fixed layout will not work for these, and space is very limited. We can't just add more columns to the existing workspace. So we started rethinking how we wanted to build a new coding workspace. So we did some research. We went to Replit, Code Sandbox, StackBlitz, LeetCode, and we realized that all of them were using a dockable layout where, in VS Code, you have your panels that you can resize, you can rearrange however you want. So our strategy was to implement something similar, but provide good defaults. And any new features could be added as another tab in the panels. And LeetCode, the current version you are looking at now, was not like that in the past, and they eventually moved to this dockable layout. And Sandpack, which is the execution layer for our coding workspace, also has some problems. So the key maintainers of Sandpack left the company. Updates have been pretty slow. And Sandpack, I've looked into the code very heavily, and it's actually only partially open source. A lot of the things are coupled to Code Sandbox, and there are some parts that are not open source and tightly coupled to Code Sandbox where we can't change. And sometimes you want to do certain things like updating a variable config, but they are hard-coded within Sandpack, and it's not modifiable by us, as a user of the library. So it also hard-codes the CDN, uses JS Deliver CDN, and CDNs do go down. So this is not great for a platform that wants to provide like high uptime. And there are tons of bugs that have been reported that haven't been fixed for very long. So we wanted more control. So that got me thinking, like browsers are extremely powerful these days. So this code you see here, it actually works. It actually works right out of the bat. You can actually run React code in the browser with just some slight transpilation, and import statements actually really work in browsers. Like, can we somehow leverage that to build like a modern in-browser coding environment? So we did that, and it's called Groundpack. Yeah, so why did we build Groundpack? So as mentioned, Sandpack has quite a few problems. We want to reduce our risk and reliance on Sandpack. And I've been thinking about this problem for over 2 years now, and we understand it much better. And we have some proof of concepts that actually worked and gave us confidence that this is something that we can solve. Yeah, and also technically challenging and fun. And this approach does have some limitations, but they are acceptable in the context of Greatfrontend's use cases. So what is Groundpack? Groundpack has two parts to it. There is the tiling layer, which is the layout system, the docking layout system, similar to what you find in many modern IDEs. And then there's the bundler, which has a similar architecture as Sandpack, but does not have any bundling, and it's much more customizable. And we were heavily inspired by Vite, which is the zero bundling tool that created by Evan Yu. Yeah, so how does Vite work? So in order to understand Groundpack, we need to first understand how Vite works. Vite in development, it does not bundle the entire application. It heavily relies on the browser to do the work of fetching the modules that are required. Yeah, so the first thing it does is it does dependency pre-bundling. So it bundles your dependencies together. So for Groundpack, we don't do that. We directly load from esm.sh based on what's present in your package.json. esm.sh is a powerful CDN. It's not just serves files. It can also bundle dependencies. It can do a lot of processing before the code reaches your browser. And Vite also relies on native ESM serving. So your application source code is served as native ESM. When the browser sees an import statement, it sends a HTTP request for that module. Vite also does on-demand compilation. If a file needs to be processed first, the Vite's dev server will intercept the request, and it transforms the file just before it returns to the browser. Yeah, so for Groundpack, because it's pure client side, there's no server. it uses a service worker to intercept the request, and the transformation is done within the service worker and before returning to the client. So let's look at some examples. So this is a minimal React app. You have the index.html. You have the index.js, which is the entry point of the app. And it loads the app.js, which is just a simple file that displays hello world. And within the app.js, it imports a CSS file. So when the browser sees this index.html, it will load the index.js file, and when it sees the app.js import, it loads this, and within app.js, it loads the styles.css file. And so this is kind of how you would see how the network tab would look like. So there's a waterfall of requests. So in Groundpack, we rely on this and we build a library around it. So Groundpack has 3 parts. I will go through them one by one later. This is the high-level API of how you would use it. So you just need to install Groundpack React, and it provides a few modules for you to use. Groundpack, which is the root layer, provides a context, and you pass it the files that you want that is part of the project. So it's a stringified version of your of all your files. Groundpack tiles is the layout layer you see, and then Groundpack preview would be the preview output, which you can interact with to test your application. So let's look at Groundpack tiles. So this is example built using Groundpack tiles. You can see that it's a layout engine that is very flexible, can be shifted around, and you can customize it. You can have 3 columns. You can even maximize it or collapse. Yeah, so this is similar to what you have in VS Code, and is part of Groundpack. And it's built using a reducers pattern. So the state is actually very simple. It's a tree where you have a root. The root is a tiles panel group, and in the group there's an array of items, which are different panels, and each group has a direction, whether it's horizontal or vertical. And within each panel, there are multiple tabs. It's very similar to your browser, very similar to VS Code. And uses a reducer pattern. There are multiple actions that you can dispatch. So there's like closing a panel, collapsing a panel, dropping a panel, splitting a panel, changing tab manipulation operations. And we wrote multiple reducers to test each of these sort of the logic needed. So each reducer takes in an action which describes the operation, and then the parameters needed, and returns the new state. So it's extremely easy to reason about and to write tests for, because when we write a test, we just have to test the reducer. We don't have to test the entire application. Just have to make sure that the reducer, which is a pure function, receives the input, returns the right outputs. Yeah, so this Groundpack layout has already been implemented on Greatfrontend. So the version that you see now on Greatfrontend is using Groundpack layout. So it's can be moved around to support any layout that you desire. And next we'll talk about Groundpack bundler, so which is the meat of what Groundpack is. So over here you have a simple React application. So, and it's able to load file dependencies from npm. So over here we have a canvas confetti library. So upon pressing the button, it shoots out confetti. How much confetti do you want? We can let's go for maximum. Yeah. So this is a simple React app that is powered by Groundpack, and it runs entirely in your browser. Yeah, so how does, let's talk about architecture. So these are the files that are being sent to involved in this project. So Groundpack React is a library that you install in your app, and inside Groundpack React, it would initialize multiple clients. Each multiple client is in charge of one execution environment, and each client will spin up an iframe, which will run the code. You won't be running code in your host web page. It'll be run on a separate iframe, so that you get multi-threading, you get security benefits, and all that. So the first thing that happens is that the library Groundpack React will compile the app. It's not in the conventional sense of compilation. It firstly reads the files and build an import map for the package.json. It merges the index.html with the default index.html and injects a script which into the page of the iframe, which will kickstart the whole chain of imports to run the application. And so there are other commands like updates. So when the user modifies the code in the editor, update commands will be sent to the client, which will be sent to the runtime, and the runtime would do something to update what is shown in the iframe. And lastly, there's a reload command to reload if there's a need to. Yeah. So let's dive into how the Groundpack runtime works. So the first thing it does is it generates an import map. Why is an import map needed? We'll talk about that later. And with the entry file, it will send. It will make a request to the entry file, but it's actually intercepted by a service worker. This service worker would inspect the file path, and based on the file path, it would perform a series of transformations. So it sees that it's a TSX file. It would run the TypeScript compiler to strip out any TypeScript types, and it will return a plain JavaScript file, or rather a JavaScript file that's executable by the browser. And then the browser receives a new JavaScript file, reads the imports, and executes the rest of the file, and so on and so forth. Yeah, so you can see this service worker is essentially kind of like a server, like the VDev server here, that contains all the files and performs some transformations before returning to the client. Yeah, so there are a series of challenges that we had to solve before we could get Groundpack working. So the first problem was that browsers don't understand bare import specifiers. So bare import specifiers are stuff like you write in your code like this, like from React, import something from React DOM, from any library, etc. This is the kind of code that we write because that we normally write. We don't write the entire file path, even though it's the path to the module, even though it's actually supported, because our bundlers like Vite, Webpack, Parcel, all these, they would map it to your local node modules, right? But in when we're coding the browser, there's no such thing. So but the browser thankfully has support for this called an import map. So you can create an import map within a script tag with a type of import map, like something like this. And when the browser sees a code like this, it would look up the import map, and these are from asm.sh, and it would fetch the code from the module from asm.sh and execute the module. So the first step in the compilation process is to turn the dependencies in package.json into an import map that so that we don't have to so that the bare import specifiers in your files work. The second problem that we faced was that most of the time the paths that the imports that we write, we don't specify the paths because our bundler would automatically try to resolve it to existing files, like if it's a .js file, a .ts file, a .json file. Yeah, but browsers, they don't have that. They want the full file path the full file path. So the solution here is to use a library called ES module Lexer. This is used by Savell, by Vue, and Vite as well to parse the file and to get a list of imports, and we'll rewrite the file to rewrite the import statements based on the files. Yeah, so this is the before, and this is what comes up after that. You see that the files have the extensions appended to it. It will read based on the available files, the object when you first pass to Groundpack, and you append the extensions. The next challenge is that import modules are cached. So when a browser imports a file, if another file wants to import that file, and it sees that that module has been imported before, it will not import it again. And that's a problem during development, because when you develop, the modules are constantly changing, and you want to load the newest version of that file. So how we solve it is the same as how Vite solves it, is to append a query parameter to the file path. So over here you can see that there's a v equals 1 query parameter, and when we change app.tsx, we know to transform the import statement to be a different one, so that the browser thinks that it's a different path, and will re-import that module again. Yeah, so this is actually not specific to the module. It's the service worker. It strips out the query parameters and looks up the file object, and serves and returns the latest version of that file. Yeah, so the fourth challenge we face is that JSX and TypeScript isn't understood by browsers. So browsers only run JavaScript, doesn't run all different flavors of JavaScript that you have. And this also applies to like the Vue or Savell files that they aren't runnable by browsers by default. So the solution here is to have the service worker intercept and transform the request using the various tools. Brevo, TypeScript are the most common when it comes to like processing JavaScript or TypeScript files. So on the left you see the original, which you write JSX, and the right side is what happens. It gets compiled into JSX calls. Yeah, this statement gets inserted, and the JSX disappears. It becomes like React create element, or like the modern JSX function calls. And types are also stripped out from in the process. Lastly, the last challenge we faced was CSS imports. So browsers, they don't support importing of CSS files. And this approach was popularized by Webpack, where anything they import is a JavaScript module. And how Webpack does it was that it turns the CSS file into a JavaScript module, and we solved it in a similar fashion. So example, if you're in your apps, you have you import a CSS file, and this is the contents of CSS file. What happens is that this CSS file gets transformed to a JavaScript module. So you create a JavaScript element, a style tag, and then you append the contents of the CSS file. In this case, body color rate, and append it to the head. Yeah, so CSS files in the end become JavaScript files. And when a browser receives it, it will inject that CSS into the page. Yeah, so to summarize, this is on the left is what you write, what you see in your projects, and on the right is what happens, the necessary transformations that has to be made before the browser can run your code. So you can see that import map is created, the file paths have a version prefix added to the back, and any JSX and TypeScript file parts are converted, stripped away, and CSS files become JavaScript modules. Yeah, so we built a plugin system so that the core remains lean and it handles anything that is like specific to the specific framework. So there are like React, Vue, Server, Angular, TypeScript, JSON plugins to handle different kinds of file formats. And the API is very similar as Vite plugin, which is also inspired by Rollup. So this is an example of Server plugin. So when a file is requested, the service worker will load all the available plugins, and it will check the file name. Check that if it ends with .serval, then it will perform a transformation here. It will load the compiler from esm.sh based on the version specified in the package JSON. It would transform the CSS file. Transform the serval file into it will extract out the CSS and JavaScript from it, and return it to the client that requested it. Yeah, so to put it to the test, we tried supporting Repo.js in Groundpack. Repo.js is a new JavaScript framework by Dominic Ganaway, who is the creator of Inferno and Lexical. He created this new JavaScript framework called Repo, and we added support for it in under half an hour. Yeah, so to prove that it works, I can change it. Yeah. So this is a new JavaScript framework that Groundpack easily supports, thanks to the flexible plugin approach that we use. Yeah, so that sums up how Groundpack is built. And so we also face some limitations with Groundpack, so which is very similar to the limitations faced by Vite and when it first launched. So the first limitation or downside is that there are HTTP request waterfalls. So because we don't scan all your files, right, at the start, it's based on the entry file, and the entry file imports some files, and the imported files will import more files. So you can see how these requests can lead to a waterfall. But in the case of Greatfrontend, where the questions are quite small and the apps are pretty small in nature, the waterfall isn't that deep. And because service workers, they're essentially local, they are within the same your device as they run on your device, the latency is near zero, so it's like a few milliseconds. And Groundpack can only run client-side only apps because there's no file system or Node.js runtime. And if you need a Node.js runtime, Stack needs to have web containers to do that, so they're able to run Next.js apps within your browser. But that's a much heavier approach. Whereas Groundpack is extremely lean and relies a lot on the browser for resolving imports and importing the modules. So Groundpack is feasible for small demos, coding examples, and very self-contained programming challenges. Yeah, so the current status of Groundpack is that the layout and docking stuff is done. We also have support for React, Vue, Server, Angular. And also you're able to import any NPM packages that run fully on the client, as you saw from the confetti package that we're using just now. So it also has support for CSS modules, console. It's a console component as well to show the different log statements that you might have. There's also in-browser test runner and showing any compilation errors. And however, there's still quite a lot of work to do before we're able to ship it. So hot module reloading is one important and very tough challenge we have not solved yet. But if V is able to solve it, we should be able to learn from their approach and implement it within Groundpack. Yeah, so there are other quality of life improvements like recursion prevention, on-demand loading of plugins, and caching of unchanged files. Yeah, so that's all for my talk. So I'd like to give some credits to some of the key people and innovations involved. So I'd like to thank the Greatfrontend team, Nitesh, Harshit, and Yuhang for their work on the Groundpack project, and also Code Sandbox team for Sandpack, which we read. We spent so much time reading the code and learned so much from their approach. VT and especially Evan for creating Vite and like the inspiration behind the approach for Groundpack, like ESM.sh team, and also ReMDX team for the framework that powers these slides. Yeah, so thank you. If you have any questions, feel free to reach me on LinkedIn or on X. Yeah.
All right. A great start to our remote day with a great talk by Yangshin. Yangshin, before you leave, I have one very important question for you. Why did you choose the name Groundpack? Is it because ground is more solid than sand?
That's a very funny question. Yeah. I wanted to choose something that similar to Sandpack, and we intentionally chose design our APIs to be very similar to Sandpack for ease of migration from Sandpack. And so I guess Sandpack is because of code sandbox, and Groundpack is because it's like a playground. Yeah,
Okay.
that's why we call it Groundpack.
All right. Yangshin, thank you for joining us. And yeah, as he said, he is available for further questions on LinkedIn and X. I still have trouble calling it X. Yeah. Thank you, Yangshin.
Thank you. Thank you.
Bye. All right. Our next speaker is one of the, I would say she is one, sorry, not she. They are, one of the very renowned developers and educators that I have known. Not personally, but I've followed her on Twitter and other places. She has literally helped shape millions of developers, and she has helped them learn not only React, but about the modern web. She has worked. Sorry, Rachel. Why do I keep saying she? I'm really sorry.
Don't worry
They,
about it.
yeah, they have worked at many places like Mozilla, Microsoft, and Meta, and they have created not just world-class documentations, but very cool animations as well. On a personal note, Rachel loves sketching in coffee shops. Rachel, any recent sketches that you're proud of?
Yes, actually, I was doing watercolors at Cascadia JS recently. I think they have a card coming to them, so you might see it on Twitter if they share it when they get it.
All right. Here's Rachel Lee Neighbors with a talk about the death of browser. Scary. All right, Rachel, take away.
It's good to be here. Am I sharing my screen? Are you able to see the front slide?
Not yet.
Let me do that. Let's see. It's always a little fun when we get set up. How about that?
Yeah, got it.
Woot! Okay. Hello there. I am Rachel Lee Neighbors, and this is version 3 of this talk, Death of the Browser. And thank you so much for that wonderful introduction. Just to recap, I've worked on standards that powers today's web with Mozilla on Firefox, DevTools, W3C on web standards, Microsoft's Edge browser, and even on everyone's favorite React, building the some people had a baby during React during the pandemic. I had react.dev and react native.dev. So a lot of fun. Let's see. Before my big tech career, I made comics for teenage girls on a platform. It was a website called girl.com, and it was powered by ads, and it had 400,000 weekly readers from around the world would read my comics. And these are other teenage girls. And this led to me building my first website. This was Mangapunk. It was a Drupal portal designed to bring together young women who loved manga and comics just as much as I did. And it's how I got started building for the web, this sort of lovely, cozy web feeling. But lately, I can go an entire day without opening a browser. This is, for instance, me looking up puzzle solutions for a video game I like playing called Blueprints. I'm using a personal agent. It's open source. It's called Goose. And I'm actually wearing a goose shirt. You can't see it right now, but I'm a big fan. Consider it the open source alternative to Claude or to ChatGPT. You get this client and you determine which sort of LLM you want to use. You can use a local one, you can use a remote one, and it can go out and search the internet and return and summarize things for you, among many other things that you can get it to do with tools. So it's possible for me to check email, to correspond with people, and to even look up information without having to open a browser these days. So non-human traffic is actually up about 18% from the same period last year and rising. When I say non-human traffic, I'm talking about bots, crawlers, etc. It's on the rise. And there are more and more crawlers getting information to give to LLMs and train them on, but also agents acting on behalf of human beings. And AI-based search providers like Perplexity are actually starting to cut into Google's previous monopoly. They're impacting search traffic. During the FTC hearings, Eddie Q from Apple testified that searches on Safari dipped for the first time in May. And Eddie says this is probably because of things like Perplexity and ChatGPT. People are asking questions of the magical crystal ball of human knowledge that are these LLMs, rather than sifting through search engine results. So how did we end up in this situation where the web is sort of a nice to have that we scrape for information to feed our magical crystal balls? Well, platforms happened. Facebook, Instagram, YouTube, Amazon. These things were engaged in what is known as the enshittification of the internet. People moved off their blogs and forums and onto platforms where they were then held hostage. This term was coined by Cory Doctorow to describe the life cycle of platforms from Amazon to TikTok, and I'll break it down for you here. First, you acquire most users by directing profits to them until they're locked in. I'm going to use Amazon's Kindle program, Kindle being the ebook publishing technology. You get a little device you can read things on, and you can publish your book to the ebook format on Amazon. And at first, that was great. There were grants being offered, there were bonuses to encourage more and more people to create to use the Kindle and create for it. You attract suppliers by directing profits to them until they're locked in. Let me rephrase this. In the beginning, the Kindle was cheap. It was advertised as an easy way to take all your books with you wherever you went, and Amazon sold them at a very low cost to try to encourage more people to buy Kindles. And then Amazon attracted suppliers by directing the profits that they were acquiring to them. They created grant programs to encourage more people to publish on Kindle and to create more ebooks. And then once they had reached a critical mass of people reading ebooks only on Kindle devices and people creating ebooks only for the Kindle marketplace, they started introducing more predatory policies, like taking 60% off of the profits for books that were published in more than one ebook market. These things are questionably legal, but there's no law that prevents it. This solves the age-old underpants gnome conundrum of, if phase one is collect users, what's phase two? It's collect suppliers, and then you squeeze them both for profit. Now, platforms, they promise the ease of consolidated interactions. Just go to Facebook and you can see all of your friends, and it'll be a great interface. It's not like, having to go to MySpace and use their terrible search functions, etc. You get to just see your family's pictures. It'll be so easy. Just, invite all of your friends and stay here. And then eventually we'll bombard you with ads. And you'll have nowhere else to go because all of the blogs will be shut down because no one goes there to read them anymore. They just want to see those posts on Facebook. But to keep these users captive, they have to lack interoperability. And you could see this when platforms started doing things like when Twitter removed its RSS interoperability, or when Facebook shut down its API so you could no longer build apps for it, and started decreasing the visibility of posts that linked outside of Facebook, trying to keep people inside. Essentially, platforms will hold their content hostage with pricey or no APIs, and they hold users hostage by owning their networks. This means that to get anything done on the web today, we have to flip between a bajillion different platform tabs. And this is me just trying to keep up with the web agent community, just looking for a basic search on news across multiple platforms. I have to track them in a spreadsheet. And you say, well, what about an aggregated experience? Well, even if we want an aggregated experience, this is Buffer. It allows me to post to multiple different platforms. Once again, this is another platform, and it's something I have to pay for. Organizations can't afford their own platforms or APIs, so they just have to dump their information online. There's no way to aggregate or alert customers beyond an email at best, or hoping that they will chronically search. This is a dog rescue in London, and they post pictures of them on their website, but usually they also post them to other platforms like Facebook, etc. It doesn't make sense that they're having to publish in so many locations when they have a single source of truth right here on the web. And the enshittification runs deep. If the internet is a vast sea of unstructured content with spotty and clunky interoperability at best, it begs the question, why are we still using a browser built by an ads company to navigate it? Chrome is the top dog right now. It's had no major interface changes aside from Gemini in the past 5 years. It almost got sold off to Perplexity, and it currently owns 70% of the market share when it comes to the browser market. 70% of people browsing the web are browsing on Chrome, but it's pretty stagnant. Search is, let me show you how the different teams that build Chrome and build the web interact with each other at Google. So search is Google's top of funnel to ads. That makes them the money. It's their number one priority. It keeps the company afloat and makes them billions of dollars every year. Now, for people to use search, they need a good experience visiting websites. Yeah, this was something that came up when they were, this came up when mobile apps jumped onto the scene. Google had a moment where it was like, wait a minute, if people start using apps instead of using the internet, that means we won't make as much money from ads that people see when they're using the internet, when they're visiting websites, when they're using search. We need to make the web more competitive. We need to make sure that people will still use the internet and that it's a pleasant experience. So they built Chrome, the browser, which is the client, the UI, the user interface that is used for navigating the websites. And they also have the web platform team, which invests in building APIs and standards with the W3C and TC39, who are responsible for CSS and JavaScript and HTML standards. Now, these teams don't always want the same thing, the search team, the ads team, the browser team, and the web platform team, but they have really good synergy. Google does a good job of hiring altruistic humans who will work tirelessly on the web platform for the free and open web. Meanwhile, the ads team benefits greatly from a free and open web. But interestingly enough, Google's been trying to replace the web for years. If you might remember accelerated mobile web pages, or AMP, this was essentially a way for people to not build a website at all, but to take their content and put it on a Google domain that had basically really stripped down, hyper-efficient presentation layer. The problem was, though, that it was making essentially a shadow copy of the internet. And for a while, if you did release an AMP version of your website, you would get priority in Google search results. And this was a well-known and publicized fact. Search and ads wanted to keep people using the web more than apps, even if it meant making a shadow copy of the internet. Nowadays, visiting pages isn't even necessary with the AI-enhanced Google search. If you're looking for that solution in the puzzle game, you'll just read the AI-generated summary. You don't have to visit a site. You don't see you don't see ads here right now, but I'm sure there will be more ads added to this as this feature continues to pick up in popularity. What this means is that search and ads will get fed. They will get money. But the creators who created the content that this overview was created from, they don't. They don't have eyeballs coming to their website viewing their ads. It doesn't happen. Pardon me, I still have a little bit of a cough. So at Google I/O this year, Google made it clear that it is betting on an agentic web. And since the FTC came down and agreed that Google could keep Chrome, we've seen increasing amounts of Gemini features being released in the American market that support that it's betting on this agentic web. And this means that it may no longer be supporting the open web as we know it. And this begs the question, is Chrome the new Internet Explorer 6? And is the internet that we've built with Google the internet that we always wanted? Well, let's take a little look at how the web is changing and how we're changing with it. So I mentioned that so far the web has mostly had two kinds of traffic. Human, which reads and perceives content, including ads, and crawlers, which index and scrape content. And for the longest time, the only crawler we needed to worry about was Google. And we could tell Google how often we wanted it to visit our web pages, whether or not we wanted it to index those web pages. And it was a fairly friendly relationship. The entire industry sprung up around optimizing for Google's crawler, search engine optimization. Now there is a third user, the agent. This agent performs tasks on behalf of humans. It's almost like a bouncer, a gatekeeper. It's not going to be suckered in by your ads. It's not going to bring anything to the user that the user didn't request. And in a way, this is the worst possible invention if you own a browser and you make money off of search and ads. Now, there are upstarts and startups like Dia and Strawberry that are building browsers that have agents built into them. This is pretty cool. If you've tried one of these agentic browsers, they do automations incredibly well. But even big browsers like Opera are building AI into their browsers. This is an example of Strawberry browser. They just got their funding yesterday. Congratulations, Strawberry. You can find them on Twitter, I think, as AI_browser. Anyway, check them out. Lovely small team of youngsters in Sweden building this browser with the idea that it can automate things like generating this report just by, you record an action and you can have it replay it for you. These are, like I said, they're agents essentially that have a human visible window attached, or you could say they're a browser with an agent strapped to the side. I used Comet to reach out and connect to people who are attending the same conferences I do. This is, I will send it to a conference page and I will say, find these people on LinkedIn. And if I follow them already, tell them I look forward to seeing them. If I don't follow them, send them an invite and tell them I look forward to seeing them. It's quite effective. I wouldn't have the time to do this in my day-to-day life. But do we actually need the visual portion? Do we need a browser? Remember at the beginning, I showed you how I was able to go through a day without opening a browser. We went through this once before when we had the advent of mobile phones. We worried that the web would become just a data layer. And in October 2016, mobile traffic surpassed desktop traffic for the first time. Apps use the same protocols and infrastructures to shift information that the web does. But people use apps more often, especially as they spend more time on cell phones than they do on their desktops. Ostensibly, this is because mobile apps offer a richer, more custom and nicer feeling to use. But you know what else is rich and adaptable and gives you a wonderful user experience? A personal agent that's customized directly to you and knows you better than anyone else. So this is how I regularly scan the industry for awesome job opportunities. I strung this up using Notion and Claude code. And I've had far better luck with this system than I have using LinkedIn. It's very clunky, a very basic experience. People have contacted me and said, I want to know how you did this. Get yourself an LLM and get yourself some Notion, and it's like just telling it how to search different sites, put opportunities into a database and surface them to you and then track them in a progress sheet. It's not that hard to build. Anybody could make it. But the point is that I have such better results with this. I was able to land 9 different interviews and 2 offers out of them. Recently, I did a hackathon with client of mine, Agent QL. And this young man made a voice-based browser using nothing but LLMs and APIs that we have lying around today. This is a browser that responds to voice input, reads you pages, summarizes pages. Turns out LLMs are pretty good at reading web pages even when they aren't marked up to be very accessible. Who would have guessed that the thing marked click me, even if it was text, would happen to be an interactive element? An LLM guessed. It's seen that pattern before. And there's this concept of adaptive user experiences that we generate user interfaces on the fly based on the information and the context. This is an example of LCAR from Star Trek. It adapts to whatever information the person requests or needs to see. We're starting to see things like this picking up in the MCP UI world, which I'll talk about in a minute. So agents use the web as the API, and they replace both apps and browsers. They're the ultimate client. There are 5 capabilities that once they evolve, the browser as we know it, and probably apps, are gone. They will be used mostly as an escape hatch to do things that are difficult to do. You'll see many talks about these over the next year, so I won't dive into each of them because we only have so much time. But I'll break down in order of difficulty each one of these pillars. There's interoperability, how agents talk to each other and how they talk to resources. MCP, ACP, agent to agent. These are the current competing. What is the word again? Protocols. Thank you. We're still at the protocol development stage. It's an exciting time. On-device AI, or local models that are faster and cheaper. If you hear the word SLM, or small language model, this is referring to language models that are so small that they fit on your device. You can get very good performance out of a language model distilled from a larger model that's only like 8 gigabytes big. Identity and authentication. This is the biggest challenge, but the agent community is actively solving for it. This is delegation, permission, security. How do you tell the world that this is an agent that's been given permission to act on your behalf? What happens when an agent is acting on behalf of a company and not an individual at that company? These are questions we really have to sort. And compensation, because this model breaks how the internet currently runs. Finally, we're having conversations about micropayments, access fees, subscriptions, ads. All of these need to be retooled for a future where people are essentially interacting with feeds as opposed to websites. And the hardest one is discovery and discernment. Agents are very good at retrieving information, but they're not very good at discerning when a blog post was written by a reputable source versus just some person trying to increase their search engine optimization. Right now, agents are about as reliable as Google's algorithms back in 2013. So the good news is that those algorithms already exist. So interoperability is the key because right now we have a couple of different protocols, but the thing that makes agents beautiful is that they can talk to each other and to many, many different services. We have something called function calling or tool use. And this allows foundation models like Claude, like ChatGPT to connect to external services and APIs. But these are typically custom for each model. A tool built for Claude cannot be used by ChatGPT, and they're focused on models using tools versus APIs that are talking to each other. So that's why we have these. There's actually 11 of them, protocols in the running for this agent-to-agent communication and agent-to-resource. The most popular that you'll hear about for the next year is MCP, or Model Context Protocol. And this is great for surfacing content, tools, etc. as a source to agents for them to use. It really focuses on allowing agents to access and manipulate information they'd find on the web. We talk about sustainable AI a lot, and the truth is the only sustainable AI is small AI, which happens to be a better option for consumers because it's cheaper, it's faster, it's not round tripping with an external server, and it's more secure. Your information stays on your device. NVIDIA recently did a study that found that small language models are sufficiently powerful, suitable, and more economical than the large language model cousins in systems where agents are repeatedly tasked to perform specialized tasks, like responding to emails. To get an idea of how big and how small these are, you can see that we have so many small language models that come in under like 8 gigabytes even. And, these could be run easily on your own device, your own mobile phone. I currently actually have a Pixel 10 Pro. This is one of the first commercially available phones that has a small language model in it. It's one of the reasons I bought it, just because I wanted to test how much I could do with it. Expect those to show up more often on more devices. Identity, authentication, and authorization. This is where we're identifying when traffic is coming from an agent, when an agent is asking to do things on behalf of a user, and figuring out what subset of permissions and access that agent has. This is the current big challenge, and this is preventing the most agents from coming to production inside enterprise environments. It's actively being solved. Companies like Arcade are focusing more on what the agent is allowed to do with tools and authorization. The identity part is the less challenging challenge. And then there's payments. Like I said, ads only work with human eyes. The ad-supported web is officially broken. It's officially broken. It's officially dying. It was already losing traffic in 2016, and now we can access all of this content without ever having to watch one ad on a website. It's the end of journalism websites as we know it. There's a great article from Stratechery about how the protocol layer should have a mechanism for payments built into it, and AI should build an auction mechanism that pays out content sources based on the frequency with which they're cited in AI answers. The good news is ads tech basically already does this. It just needs to be repurposed and decentralized. I know, easier said than done, right? There's this interesting new licensing model called RSL, or really simple licensing, that Yahoo, O'Reilly, Reddit, and more are proposing. And it's interesting because they've proposed this licensing agreement where you can declare what you want to be charged for the use of your content right there on your website. But they didn't actually partner with any model builders to get buy-in for that payment. They don't need to. They're collaborating with Fastly to work on a way to hard block crawlers unless they pay up. So it won't be an opt-in sort of thing like robots.txt. Now, Skyfire. There are payment providers like Skyfire already coming along. I saw a great demo of Skyfire using 402s so that companies could charge for crawling their web pages. This is the hot thing right now. Even big money wants to solve for this. At last, we're talking micropayments on the web. MasterCard announced Agent Pay, an AI agent payment network framework. Like I said, discernment and discovery are actually already solved. Facebook and Google determine what to show you without generative AI. But doing these things in a decentralized way is hard. These are proprietary algorithms that they're using. And SEO doesn't work with AI the way it does with traditional indexing algorithms. There's a rush of companies right now trying to capitalize on what's called generative engine optimization, or GEO. In the future, though, I suspect local adaptive recommendation systems will be selling points of devices that are running specialized models. But until then, AI answer engines like Perplexity are very happy to sell you API access. We may have to rely on centralized indexes and proprietary algorithms for discovery and discernment for a bit longer. This area is still to be determined. But I suspect what people will use to interact with the web might not be called a browser in the future. Don't get me wrong, we'll still use a tool to interact with and browse the information superhighway, but we might not call it a browser. When all 5 of these pillars are fulfilled, we're likely to see a personal agent overtake apps, sites, and operating systems, an agentic operating system, as it were. I predict that browsers will actually drop into business and legacy use cases, sort of like we open up a terminal to debug a program. And you need look no further than Atlassian acquiring the agentic browser Dia's creator, the browser company. It makes sense. Atlassian builds workflows for businesses. So welcome to the era of AI browsers. How do we build for the browserless web? Well, if you have if you Model Context Protocol allows you to make content available as resources, and you can also make APIs available as tools that an agent can access, CRUD operations and even more complicated things. NL Web launched at Microsoft Build, and it's like an adapter for your content. It's created by the creator of RSS and Screamer.org. And it basically spins up an MCP server for your existing website. You can set it up right now and get yourself an MCP server hosting your content and your tools right away. You can create an LLMs.txt as part of your build process. It's like a sitemap, but for agents. It's written in Markdown instead of XML, proving that every generation of engineers remakes the world in their own image. And for content, people might need to feed into an LLM on a case-by-case basis, especially if you're developing like a developer tool or, a design system. If you're maintaining documentation, these copy to Markdown buttons can really help. With the React team, when we were building the React documentation, this was the #1 request people had. They just wanted to keep a local copy of the React docs for traveling. So what's good for humans is often good for their agents. Now, sometimes you don't want your content crawled or added to an LLM's training data. Or maybe you want to screen agents from sensitive parts, making visitors continue on foot. You can use your robots.txt to tell bots how you want them to treat your site and its contents. There's a complete guide on how to set up your robots.txt to allow and disallow different companies, agents, crawlers, etc. But if you've ever built a scraper, you know that this is sort of a suggested guidelines, and that many bots and agents will disregard the robots.txt. And for them, you send them to Tarpit. You can set up an enforcement of your robots.txt using fingerprinting. And you can send bots who don't respect your boundaries on an expensive goose chase. This is a great URL that it's on Mastodon, and it outlines all the different tar pits and nepenthes that will absorb malicious or naughty crawlers and agents and put them on long, endless tasks and absorb a lot of their attention or poison what they're building. We will train them eventually to respect robots.txt. The web still needs engaged developers to push it forward, whether they're building a browser or building their own agents. I want to encourage you to think about small on-device LLMs. They're a more economic and secure option instead of just making calls to OpenAI or to Anthropic. Chrome's working on APIs that use them right now for the web. You can check it out at this URL here. And if you're building anything social, well, RSS has been reborn as AppProto, the Authenticated Transfer Protocol, a decentralized protocol for building large-scale social applications. You can see it in action at Blue Sky. So if you're thinking about building anything that connects people to people, use this. It's not AI, but it is the most AI-friendly technology that breaks us out of those platform bubbles. Check out MCP UI. This is important if you're managing a design system. It brings rich components to agents. So if you want to send people a gallery component or a shopping component, MCP UI is how you do that. Shopify is using this right now. It's gone all in. Here you can see an example of MCP UI components in Perplexity helping someone shop for hotels. So your agent's returning more than just text. Your skills in open standards, APIs, and user-centric design are more valuable now than ever. So join the MCP working group, join the AppProto working group, influence on-device AI features and standards. What we build today sets the standard for what we build tomorrow. And I think I am at time, so this is a good place to drop it. But thank you so much for having me here.
Thank you, Rachel, once again for joining us. Before you leave, I'll just ask one question. for people or developers, who are still building traditional apps, whether mobile or web, what would be your one advice or suggestion to them to be agent ready?
Actually use agents. Use them when you're coding. Try using them when you're browsing as well. I think what we're missing right now is thought leadership in the patterns. Like MCP UI is really cool. It might actually be a really good application for web components, but it needs more people who've been building design systems and different use patterns to actually contribute, get active. So I actually recommend you check out agenticweb.nearestneighbors.com. That's where I blog about the future of the web. So I would check that out, just follow along, and try to get involved in some of these standards, especially watch MCP UI, because there's a good chance that in the near future, someone at your office is going to get tasked with implementing MCP UI to work with your design system, etc. And it would be great if you were the person who were taking the lead on that.
Yeah, totally. Well, thank you, Rachel, and I hope you stick around. To the audience, I would say please reach out to Rachel to know more about about AI agents like MCP and ad protocol and everything else that they have been talking about. Thank you, Rachel.
Cheers.
Before we move to our next speaker, let me just quickly give a shout out to our gold sponsors. Brevo, Brevo is a great company that works on how to, implement smarter team communications. Firebase, obviously, I think everyone knows about Firebase. I've been using Firebase for many years. Since I started coding, I've been using Firebase. Firebase will also be giving a workshop during our workshop day to talk about their new AI features. So please try and get the tickets for that as well if you're interested. And we have Disha and company who are supporting innovation and developer communities. Finally, I would remind you again about AWS Builder Community's QR code that will keep appearing on our screen throughout the remote day. Please scan and join the Builder community to learn more about AWS and how you can be a better React developer with AWS and its many, 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 many services. All right, our next speaker is here. We have Archana Agiwale, who is a tech lead at QED42. Archana will be talking about partial pre-rendering. And before we get to that, Archana, how are you? You're on mute, Archana.
Sorry. Oh, sorry.
Yeah.
I'm good, Rajat. How are you?
I'm good too. Great to have you here. So, Archana, it was mentioned to me that you are a huge foodie. So what is the most recent unique food item that you have tried?
I'm Maharashtrian, so I always love to eat non-veg, and I am the fan of anything of non-veg items.
Okay.
The recent is, you can say, chicken ran, which is famous in Pune.
Yeah. I'm also half Maharashtrian, but my go-to dish is misal. Whenever I come to Pune, I first try out misal. All right, let's get into it. Archana, let's learn about partial pre-rendering.
Yeah.
All right.
Hello, everyone. I'm Archana Givle, and in this talk, I will talk about renderless load fast with partial pre-rendering. It's not a just technology, it's a strategy that allows us to build page that load faster, fill instance, and still deliver dynamic content to the user. So before we start, let me give you a short intro about myself. I'm a full stack developer and tech lead at QED42. I like to contribute to open source community, and I am the core contributor of Next.js and Strapi ecosystem. I work closely with the front-end teams optimizing performance for large scale application built on the framework like a Next.js and React.js. Today, I want to explore the topic that shaping the next era of front-end performance, that is partial pre-rendering. So before we start, let's quickly walk through the today's agenda. We'll look into the SSG, SSR, and ISR. Many of you guys know about this three rendering technology. Then we'll see the limitation of this traditional rendering technology. Then what is the partial pre-rendering, how it's work, and when we can use the partial pre-rendering, and then the future of rendering, and lastly we'll go to the closing note. So let's start with the challenge of today we are trying to solve. In the modern web, user expectations are really brutal. If your page doesn't load under 2 seconds, your user will bounce, and Google Chrome Web Vital reflect that through the metrics like largest contentful paint, that is a LCP. Now we done when we are developing sites, we normally did some steps like compressed image, optimize the bundle size, lazy load the component. But even after doing these all things, your page speed or page score is still not good. Then what is the issue of this low score? So the main issue of this page score is how we are rendering the page. So rendering is the foundation of the performance. If the user doesn't see something meaningful earlier, then it doesn't matter how optimized rest thing. It means when we are like showing something on a screen, but your page is important part of page is not getting load very quickly, then it's not, your page importance is getting a low. So our challenge is to improve how we render, not just what we render. So sorry. So if we as I mentioned, we'll see the three rendering methods, that is server side rendering, SSG, that is static side rendering, and ISR. So these three are like we are using from a decades for rendering point of view, but still we are not able to achieve the performance of our application. So let's start with SSR. SSR means server side rendering. In SSR, every time user requests a page, the server runs your React code, fetches the data, and generate the complete HTML page on the fly. If the HTML, then the HTML is sent to the browser, and after that React app dehydrates that HTML, and client side it makes the interactive. So with SSR, every single request trigger the fresh render on the server. That means user always see the most up-to-date content, perfect for the case where data changes continuously. Like you can take the example of stock, prices, maybe live feeds, or you can say the news sites, notification things. But SSR really excels when content is personalized, something like a dashboard. When your app is something like a dashboard, that time you need the data, like a fresh data you need every time. So SSR is very great solution in that case. But the downside of SSR is the server has to go through the entire rendering process. That is the fetching data, executing the logic, generating the HTML after that. And for every single request, even if you are even if consider your page 90% of page is static and only 10% of page is dynamic, still whole page need to rebuild from server side. So this is the one of the drawback of SSR. Because of this, it caused the slower TTFB, that is time to first byte. As user spikes, if on your sites, if millions of users hitting, then your user spike is high, then your CPU usage will also be high. So you need expensive or you need CPU with high configuration, or you need multiple CPU for load balancing things. So while SSR gives you freshness, it sacrifices the performance under the load. Our second rendering method is static site generation. To overcome the SSR scalability issue, we move to the SSG. Firstly, we used SSR. Then nowadays, many of people are using the SSG. Here's our when we are using the SSG, the pages are generated at the build time. Next.js run your React code once during the build and produce the static HTML and JSON for each route. At runtime, the web server just serve those pre-built files instantly from CDNs. So because of that, your page speed is very high, and it will automatically improve your little bit performance score. Time to first byte will be improved. And as it's a static page and it's served from a CDN, the scalability is not at all required. So it's directly served from CDN. So your CPU expense is reduced here. But there are some drawbacks of SSG, like the page, as I mentioned, pages are generated at the build time, data is frozen at the build time. When something happened in a backend, when some data is changed in a backend, your whole site need to go through the rebuild process. So SSG is great for sites whose data is like a static. It's not changing very frequently, but not good for user specific data or the sites which changing the data frequently. So after the SSG, ISR comes into the picture. So ISR means incremental static regeneration, middle ground of it's the middle ground introduced by Next.js. ISR allows your pages to regenerate in the background after the certain amount of time interval, that is revalidate time interval. It combines the SSG and SSR feature with some partial freshness. It's ideal for some static pages like a product catalogs or maybe news wala things. Still, when we use the ISR, it still rebuild your entire page at the backend after some revalidate time. So it's again causes some usage of the server. Also, whatever we gave as a revalidate time, at that time your data is still not fresh. So it's still you are serving the old data to the user. So ISR help to reduce the build time issue, but it still doesn't gives us a fine-grained way to say, hey, this section is a static, but that one should stay as a dynamic. So across these three methods, one theme keep repeating, that these all treat the page as a unit of a rendering, but in the reality, page is the combination of a static and dynamic part. So let's see in the real world context when our three rendering methods get failed. So imagine you have a product page is in the e-commerce app. The layout, title, description are like a statics, but the price, stock count, or reviews are the dynamic. So with SSR, we will render the whole things every time, but it will be a slow and wasteful. And with SSG, we'll cache the page, but the dynamic data will not serve dynamically to the user. So user will get old data every time. And with ISR, same thing will happen, as at some point the old data will serve to the users. So what if we could pre-render stable part just once and stream the dynamic parts on the demand? That's what partial re-rendering enables, and that's what we explore the partial re-rendering. So partial re-rendering give us a best of both worlds. User instantly see the static shell and dynamic part streams in as soon as data is available. The result is the instant loading experience and live data accuracy. That's exactly the question that leads to the partial re-rendering. So what is the partial rendering? Partial re-rendering is the hybrid rendering model introduced by Next.js. It's still in an experimental phase. It's built on the of the React server component and React streaming architecture. It takes based of both words, the speed of pre-rendering static content and freshness of the personalization of the dynamic data. So in simple word, PPR, that is partial pre-rendering, all static sections are page ahead of the time, and then it runs it streaming the dynamic data at the runtime. This means your users see the static shell immediately, even while the live data still loading behind the screen. So how does the magic actually work? When you build your site in Next.js with the Next.js pre-renders, all the static parts of your page, things are like a header, layout, footer, banner, whichever you feel is a static, will generate at the build time. Then when your request come to the any page, the dynamic parts, like maybe we can take the example of user data, or maybe reviews, pricing, that all are rendered on demand using a streaming. This is powered by the React server component and streaming SSR. The static part is delivered immediately, so users see something meaningful right away. Then React progressively hydrates the dynamic component once the data arrives. That's how we dramatically improve LCP. So LCP is nothing but the, as we know, largest element paint time on the browser. So when we print the static data instantly, your LCP will automatically get reduced. So visually think of your page is divided into two zones, static zone, that is the layout, maybe header, footer, banner, skeletons. Those pre-render at a build time, and the dynamic zone that contains the contains the dynamic data per request streams later. When user lands, the static zone appeared right away, improve the time to visual. So why does this matter? Because it's directly tied with the core web vital. Partially pre-rendering significantly improve the LCP, that is largest contentful pane, since the largest visible element is often static. The hero, banner image, or title, those are the LCP elements. So those we kept as a static, and those will render very quickly. So it also keeps your TTFB, that is time to first byte, reasonable, because we have not blocked the entire page for a dynamic data. Essentially, it allows you to ship pages that load faster, feel instant, and still adapt dynamically. It's a rare case where performance and flexibility truly meets. So partial rendering in a Next.js, how we can implement the partial rendering in a Next.js. Next.js has made this super easy. We just need to add one line, that is the experiment. Now it's in an experimental state, so it's a experimental PPR, that is a partial, and then whichever is a dynamic component, we just need to wrap that component inside the suspense, so that Next.js will, behind the scene, it will automatically sets up streaming, suspense boundary, and hydration. You don't need to have do anything manually. So if you keep the real world example, I tried this approach with one page, that is product page. where before the PPR, my LCP was 3.2 seconds because the data is very minimal. So my LCP was 3.2 seconds. And after implementing PPR, hero and layout, hero banner and whole the layout, header, footers are static. So I'm rendering those section using a PPR. So my LCP improved by 2 seconds. So it's like around 32% boost I get using a partial pre-rendering. Also my TTFB dropped by around 25 to 30%. So user retention improved because users saw something instantly. So this isn't a theoretical, it's the whatever I show on the screen, it's the practical thing which I tried, and this is the practical win which I get. So while implementing the partial pre-rendering in your application, I would like to give some tips like identify the boundaries, like what will be the static content, what will be the dynamic content. Also use this React server component to isolate dynamic logic. Use suspense around dynamic sections to streaming progressively. Avoid blocking a request above the fold, on the above the fold, so that your page will not get TTFB. And measure your space speed continuously. Like, don't assume if I add this small component it will not impact to the my score performance. I would suggest measure your score continuously, so that at the end of the project you will not get in a trouble that because of this small component my whole site is getting up, like my whole page is getting up slow. So how we can improve measure the performance? To prove the improvement, measure performance using maybe Lighthouse to track LCP, CLS, INP, web page test for real film stripe to visualize progressive loading. Use Next.js Analyzer bundle for static and dynamic content chunk inside. Always measure every your site before and after wherever you like integrate anything or add any component. As I mentioned, pre-rendering is something we can combine static and dynamic content with streaming things, but there are also some limitations. So partial pre-rendering solves very specific problem, how to show meaningful content fast when much of the page is stable, but it's not universal replacement of your page. If your page is mostly dynamic, you can't use there is no use of partial pre-rendering, right? If on your page the real-time data is continuously occurring, like we can take the example of stock sites where stocks are getting changed, stocks price are getting changed every seconds or every milliseconds. We can't use the partial pre-rendering in those scenario because it's not useful. Also, if your page is very much important for SEO, then also the partial pre-rendering is little bit, I can say, not to go with the partial rendering, because the data is rendering via streaming on the uh, your page, so it will not give any uh, SEO improvement point. So the key is to treat the rendering as a toolbox, pick the right tool, and each part of each use the each part of the page. The future of rendering isn't about choosing between SSR and SSG. It's about the combining them intelligently. Framework like Next.js are evolved towards streaming first rendering, where static and dynamic seamlessly coexist. And partial pre-rendering is our bridge into that world. We are moving from when should I build statically to which part of page should be a statically. Previously, we were thinking that whether I should I should implement my site as a static site, that is SSG, or whether I should go with the SSR. Now it's time to think like which component should be a static or which component should be a dynamic. That is I can say that is the massive mindset shift. Let's take a step back and recap what we learned in today's session. So render less, load fast. That is my title of today's session. So this phase isn't just a little. This phase isn't just a title of talk. It's a core philosophy behind the partial pre-rendering. We have spent years to trying render more and more interactive, more complex data, more personalized data. But truth is that the performance is about to moderation. It's about to rendering only what matters, deferring the rest. PPR is about optimizing what matters first. In traditional rendering, every piece of content fight to load first, but in PPR flips that things. What if we load the most meaningful content first, the part users actually see and care about, and stream the everything else only when it's ready. That makes the PPR so effective at improving user experience. You are not just serving the page, you are actually serving the fast, I can say, the fast page to the users. It's not about static and dynamic, it's about the hybrid. For years we had this false binary, that SSR versus SSG, static versus dynamic, build time versus request time. But PPR teaches us that the web doesn't have to choose idea. It's about the blending, being a smartly hybrid. Render the stable part once and dynamically stream that changes. At the end of the day, it's just about the user experience, the speed of your site. So if you remember one line from this entire sessions, I would suggest don't render everything upfront, just render what matter first. So think like that. We don't just need to render our app directly, just try to be a performant, and which part is which part is important for your performance. So thank you so much. If you have any question, you can connect me on LinkedIn. Thank you.
Thank you, Archana, for that really informative talk. I have one question from our audience. So Muskan Singhal, she wants to know, how is this different from island architecture?
Ireland architecture या ISR architecture?
Island architecture, where it focuses on selective iteration, where most of the page is rendered as a static HTML and small islands of interactivity are created in it.
Okay, so maybe it might be a same. I haven't I don't have any idea about Ireland architecture, but in a Next.js, they recently introduced the pre-rendering feature. Previously, they just had that three method: SSG, SSR, and ISR. So in that three methods, they don't have any specific static and dynamic wala things. So
Okay. So I'll just mention that island architecture is more component based, whereas partial pre-rendering, I think, is more page level, right?
yeah.
Okay. Thanks, Archana. And so I think people can reach out to you on Twitter or LinkedIn for further questions. and really great to have you. Thank you.
Thank you.
All right, next speaker is Tarandeep Singh. Hi, Tarandeep.
Yeah, hello Rajat.
Hi, how are you?
Good. How are you?
So Tarandeep is here to talk about designing React apps for a screenless future where React won't even need a screen to render. Wow, great. So a little bit more about Tarandeep. Tarandeep is a senior software engineer at Salesforce. He has over 11 years of experience from building everything from enterprise grade applications to AI and IoT solutions. And he does a lot of things on the side as well, like writing blogs, mentoring students, cycling, basketball, sorry, not football, and running marathons. Wow. How do you have so much time, Tarandeep?
I try my best to do what I love to. So I try to bring out time.
Great. Thank you for making the time for us then. All right. Tarandeep, please take it away.
All right. Thank you so much, Rajat. And welcome everyone to React India. I think there are some great sessions already being done on React. Let me take you to something different this time. Quickly share the screen and let me bring the presentation. All right. Rajat, can you confirm everything visible? My presentation is.
Yeah, it's visible.
All right. All right, welcome everyone. The session for today is Zero UI Accessibility, how you can design React apps for screenless inclusive future. Let me quickly introduce myself. I'm Tarandeep Singh, Senior Software Engineer working at Salesforce with over 11 plus year of experience. I'm a Salesforce and a MuleSoft certified. Already been a speaker to multiple tech conferences like IoT Show, Dubai Remain, Trailhead DX, and many more. I always try to contribute to the developer community by different blogs, by writing blogs, or by contributing different conferences like this. I'm also a certified Trailblazer guide, and feel free to connect to me on LinkedIn. I also have my official website where you can connect back. Quick information about what is going to be happening in the next 30 minutes. We're going to have a quick introduction to what is happening for next 30 minutes. Then we're going to understand accessibility today, what is Zero UI. And we're going to see some of the Zero UI techniques and demos. And then we move to inclusive designs, accessibility beyond colors. Then we're going to have some couple of key takeaways and resources. And then we have Q&A. I think you all are already a React.js developer. You're already working on different React frameworks. Some people know a lot more than me, but this is something different which I'm going to talk about today. So before that, let me show you a website that I recently built for one of our customers. It's an e-commerce website. You can look at how great the buttons are, see how that we have a navigation menu nicely built. You must be thinking, where is it? We cannot see anything on the screen. That's actually the, really, a lot of people actually see that website like this only. That's a real truth for many people. People like who are blind, who are not able to see what is there on the screen. Are we really thinking about them while we're building web apps? That's what the topic is all about. So accessibility is not an afterthought. So when we are actually planning, when we are talking to our customers, when ideating, when we are designing, accessibility should be part of our discussions. That should be happening from the day one, the first discussion we are having for the product we are building, right? So let's quickly introduce you to a couple of important points that will help us throughout the journey of this session. There are different types of disabilities, right? Most of the time we see visual disability, people who have no vision or low vision or have some difficulty distinguish between certain colors. That's very common we see day to day. There's another type of disability, which is auditory, where people cannot hear sounds or have some partial hearing problems. Then we have motor disabilities, where they have difficulty using hands, arms, and fingers. You might have seen elderly people have difficulty, or they have hand shaking while they are moving or something like that. This is commonly, so they called it Parkinson. That is very commonly we see with elderly. Then we have cognitive disabilities, where they have difficulty processing information. So you might have seen the movie Tare Zameen Par. That's one of the example they have shown in the movie, where they have shown cognitive disabilities. So people have difficulty processing information. And then one type of disability, we have speech, where people have difficulty speaking or producing speech. So they use sign language while they're talking to someone. Then we have photosensitive disabilities, people who are vulnerable to flashing lights, rapid animations, and those things. So you see there are a lot of different disabilities. Are we really capturing them while planning for our application or any web app or any mobile app we are building? Are we really capturing them? That is something we're going to discuss more deep inside. There are different ways companies are offering services and products to make sure we capture a wide and different wide spectrum of people. So example, there are apps which can interact with voice. You can discuss, you can ask question with a voice. It reverts back also with the voice. That is one type of application. A lot of smartwatches now also come with haptic feedbacks. There are different type of vibration combination that comes when there is a notification that comes out. It's a great feature. And on top of that, this is more type of accessibility, where people are not able to interact with the screen. They interact with the different type of vibration combinations. Then you have screen readers, very commonly used apps, Chrome extension, where people can interact on the web with voice. So they can just connect to the headphone, open the app, and it will navigate the user on the web app. Then we have a home assistant, Alexa, Google Home, which help people to interact with the voice. And then we have cars like Tesla or any autonomous cars, where user don't have to drive themselves. There will be a system which is driving them from one location to another. Again, different type of accessibility that you can think about. Apple also has like a feature like eye tracking. If you're not able to use your mobile with hand, Apple also launched eye tracking, where you can move your eyes and you can control what action you need to perform on the iPhone. So these are different type of ways companies are thinking, and they're implementing that in the system, where they see the user might not be able to interact with different type of ways. So traditional accessibility is not just about ARIA tags or screen readers, right? So we all must have heard about ARIA tags. All our developers, we must have heard about ARIA tags. We must have heard like people saying, make sure your website is compatible with screen readers. Great. I think that's another great thought we all should have. But there is something on top of that also. So what is accessibility today versus what is zero UI? Let's understand this point. Zero UI means you're designing experiences where the interface disappears, right? So where you don't have a UI, I was showing you the website initially. For the user might be like this blank screen. How will make sure those people can also interact to our website, with different type of disabilities. So for people who are not able to see, definitely they can use screen readers, but what other disabilities? How will those people be able to use the experiences? That is what we can think about going to zero UI and making our apps more accessible to more spectrum of people. Accessibility that we know today and that we use in all our application is semantic HTML elements, ARIA roles, keyboard navigation. For people who are not aware about these things, I'll quickly give an introduction to these points. So when we say semantic HTML elements, that means making sure we use the right HTML element for the right type of element on the UI. That means I can definitely create a button with a div, putting a style sheet and show that experience like a button. But will my screen reader able to handle it? No. When you click on tab, the div will not be able to be on the focus. Button will be in focus. So that's how screen reader apps also work. They also understand, is this a button or is this a label or is this something different type of element on the UI? So we have to make sure when we are using HTML elements, make sure you use the right element, buttons, labels, or use header to distinguish between what these type of elements are. And then ARIA roles and attribute, make sure your elements have the right ARIA attributes so that when screen reader picks up that element, it knows what to do and how to perform an action. Like example, you define the role, and also like ARIA disabled, which tells the system that you can ignore this element and move to the next one. If there's something you can say, this need not need to be spoken out or action to be taken by the user, you can skip those elements. So those type of elements you need to clarify for the system to understand and perform accordingly. And then we have keyboard navigations. So I'll tell you a simple example of models. So we generally use a lot of models in our apps where we show a lot of information to the users. Generally, we have a cross button, the close button on the right side of the corner. But think about people with Parkinson. They might not be able to move mouse so fast, or it takes a lot of their effort to close that model. What if we can give them an escape button shortcut? Then as soon as you click on the escape, the model will be closed. Or the tab movement focus. So as you click on the tab, you just give it a try on some website. Click on the tab button, try to navigate to different elements on the UI. It will move. A lot of time what happens is it sometimes moves to the first element on the page, sometimes second time it moves to the last element, and then comes to the middle of the element. It's such a bad experience for the users who are not able to move in a sequence when using the tab. So making sure your website is compatible with the keyboard navigation. Have an enter also works for you. So when someone click on enter, you should be able to submit the form for them, or perform an action for them easily without them to always use the mouse or always use some type of things for them. So that's accessibility, what we do today. And but there are limitations. What are the limitations? This always relies on a visual interfaces. That means you always need to have a website or web app needs to be built with these type of standard V's, so that whenever a screen reader apps comes in, it can start picking up things from the UI. Great. But it relies only on the visual interfaces type of experience. But screen readers are also reactive. They're not proactive, right? And it only works if user can use a keyboard, mouse, or actually see a screen. So any of these three things you need to have to make sure that user is able to interact. If user is not able to use a keyboard or mouse, the screen reader app might not work for them. Also, it doesn't consider environmental and sensory context. So what is the environment where the user is sitting? It doesn't consider that. We'll talk more about that, what is environmental and sensory context, while we move into the session. So what is zero UI? Think about if your web app or a mobile app can interact with a voice. It can speak. It can listen to what user is asking. It can understand the environment user is in. Is user in too much bright lights, or user is in dark room? Because I already spoke about different type of disability. People also have a different type of disability where they cannot, they cannot get too much light on the eyes. There's challenges while reading. Even we also, a lot of time you must have tried while going out, we have difficulty while reading on a phone when there's too much sunlight outside. So how we can adapt to that type of things, that is another zero UI. Haptic feedbacks, how we can use the power of vibrations in our devices and keep that also as part of the experience for the end users. So if you're building a mobile native app, React Native if you're using, you can definitely incorporate such features inside your app so that user who are not able to interact with the screen touch can interact with some other way also. Maybe you want to give some notification to them, maybe use haptic feedback. Or it could be like make sure your mobile app contrast changes while user is interacting and based on the environmental cues. So if you guys have used Google Maps, it actually changes the background color if you are using in the morning or if you're using in the evening. Based on the light around you, it changes the background color. So just that our eyes can contrast, focus on that particular element on the UI. Then you have smartwatches. That can also be an experience that we can create for them for easy accessing the application. Then we have the Alexa or Google Home, any of those type of experiences. Then IoT sensors can be used to create those type of experience for everyone. Let's understand a couple of techniques that I found are very straightforward to implement, and you can start implementing from day one into your applications based on how your experience is and what type of audience you are trying to work with this. Voice interactions. Let user interact with voice instead of screen clicks. And how do we do that? A quick code snippet here. I'll also show a quick demo also for this particular feature. So think about we using a straightforward speech recognition, WebKit speech recognition from the standard browser function. You can use that, and as soon as user speaks something, it basically listen to that event and you can perform an action. Let's example for now, you see on the screen, I have kept if command includes buy, just make an API call to make a purchase for the user, right? So now with the power of AI, you can make it more advanced. You can understand the context of the user. What is user asking? Is it like only asking for something, or is it something interested to buy? All those interactions, you can now make it smarter with the power of AI. So just to quickly show what demo looks like. So you can put like a command has and buy. I can make an API call and say, I made a purchase for you. This product is now something which I've done. So without the interactions physically, I can have a two-way communication with the system and get my job done, right? So one quick demo on this. So this is an interesting JS library. Give it a try once you get a chance. So you can talk to that and website will react based on that. So let me try. Hello. Hello. Yeah. Show me cute kittens. Show me a laptop. Show me a computer. You see how based on my inputs via voice, it's able to get me the result very faster. So if we know people might have difficulty in interacting with keyboard and mouse, we are giving them opportunity to interact via voice instead of manually typing everything or getting to click on multiple buttons and all those things. So we're going beyond UI with more of interaction. So there's a JavaScript library. You guys can give it a try to see how that really works. You can perform any action. You can get system details out for the user just with the voice. So that's a first way of how we can make our website more accessible for the users. Then we have a voice output. It works hand in hand with the voice input. So whenever you want to speak out some information for the user, so now that we understood user is interacting with us using voice, we can also respond back on the same type of experience for the users. So you can use a speech synthesis, utterance functions, and they have all type of features that is great. And you can have multiple language supports. There are, I think, multiple Indian languages also supported as part of this thing. So you don't need to struggle, need to build custom things, go and implement this API into your React app, and you can start using it. So again, it doesn't need any third-party implementation, nor third-party integration with this. I think I have a React app also running based on this. I think I might not be able to play the audio on the system, but just to give you a quick code look at, this is what I'm doing. So I'm just having a button where I'm putting a click event. As soon as someone clicks on that, I'm asking to speak some word. So it could be like profile updated successfully or any other information you want system to speak, maybe on a click of an action. This is what I'm doing for the purpose of demo, but this could be working hand in hand with your input type of voice commands, where user says something, you can speak back again the same thing as directly from your app, right? So as straightforward as that, you can make sure your app is supporting these type of features. Then we have sensor-based adaptations. We can make sure UI adapts automatically based on environmental cues. How does that happen? So if you see the right side, there's the demo which I'm showing. Again, this feature is not available in all the browsers. Make sure you check the compatibility of the browsers and make sure the device has that sensors available in that. So what happens is that if you see, based on the ambient light value, we are changing the color of the background, right? So we are changing it to dark and light, but even you can also change the brightness of the page just to adapt based on where the user is. Again, this feature might not work in every browser. You need to put on experimental feature enabled. The reason is the security. So they have turned off most of the browser for the security reasons. So if you see this one, you can definitely try, or even if you're building a React Native app, you can implement such features like how Google Map has also done it. You can adapt to the light sensor values, and based on that, have your app also have the similar type of experience for the users. Again, there's an ambient light sensor for the browser. You can read the values, and based on that, you can start changing the field. All right, so we'll move to the next point, which is haptic feedback, where you can have patterned vibration alerts. So if you are a React Native developer, or if you are building mobile apps for any type of experiences, you can use vibration as one of the things to showcase, to actually interact with the user. So if, for example, there's a one beep, one type of vibration, it might be like we have to tell the user about the message that is received, or if there's a continuous vibration after every 3 seconds, the user might get to know there's a call being coming from the user. So you can define those type of vibration patterns, and you can use that for the user experiences. People who are not really interact with the UI, these people can also interact to vibration. So that is another way how we can use that. All right, so now that we know a couple of ways how we can interact with user instead of UI experiences, you can decide, you can see which one really works for your use case based on your audience, based on your customers, what really makes sense for them. There's one more interesting point I wanted to highlight right now: inclusive designs and accessibility beyond colors. I love colors. You must have seen on my presentation, I have so many different colors I'm using. But thinking about accessibility, there are a couple of things I want to highlight right now. You see two designs here, one on the left-hand side, on the right-hand side. Just give a second and think about, is there a problem that we see on the left side input field? You might say, yeah, looks similar. They don't have a clear message that this field is empty or the icon. Exactly, that is there. But that is not about experience. Might be that app have a different type of user experience, this type, different type of experience. But this is more about accessibility, right? So I was talking about the color blindness that people might have. They will not see this red color as a red color. They might see this as a brown or some other color, right? So for those users, the people might not be able to understand if this field needs to be filled or this field needs to be required field, because we have no other information. When you click on the submit button, they are seeing something is a problem. What's the problem? Because the red bounding box says it's not looking red to them. So that way you're not going to interact directly with the user. So how about if we put that a clear message or an icon to clearly tell user, if you're not able to understand with the color, we have a message for you, right? And you also have an icon to understand what is the thing, what is the, the form is asking you. Similarly, have a look at this one. The traffic light. Again, they also have a red color. People might have difficulty at looking at the red color, right? Might be for them red, green, look very similar. How about if we change this to something like this, where along with the color, we are also showing in the form of an icon. So that way, user not able to see the color properly, but they will be able to see the icon shape, right? Generally, for the license and all the traffic thing, we definitely need to have the color blindness test cleared. But this I'm talking about in terms of designs, how we can make sure our designs are accessible and for everyone that is using our application. All right, so a couple of key takeaways that I think are really great when you're building an applications, and you can think about beyond, just putting up elements on the screen. One thing is make sure your app has a keyboard, has a mouse, and has a touch accessibility. That means people will be able to use it either of the three ways. That is bare minimum we should definitely think about. If you can go beyond that by implementing, the voice interactions, you can also put in different type of environmental cues. Again, great. That is another level of experience that you're creating for everyone who's using an application. And again, it depends upon your use case. And like it'd be like a McDonald's, you're putting a kiosk. You need to have an interaction with the user for ordering a burger. That way, you can have those type of features implemented there. Also, there's one of the things which I found interesting is when you're actually building a web form for our users, try to autofill by default with a lot of information. User don't have to enter again and again. And a lot of time what we do, we might mistake, we refresh the page, try to autofill back again for the user, store it somewhere in the browser. So user don't have to fill again and again. Again, this is an experience for all our users, but on top of that, we're also thinking about people who already had difficulty filling a form. By chance, they have clicked on the close. Again, it's again a difficulty for them to fill the form again. So if you can think about them in that way, amazing. Also go through the accessibility guidelines already published online. There is a standard way how much size of the button should be, right? Minimum size of the button. So I'm talking about like people with Parkinson's. Their hands will continuously move while they're using the mouse or a keyboard. So they might not be able to click on a button very easily. There's high chances the button is small. High chances they will click somewhere outside or not be able to click properly on the button. So if you have at least a bigger size of button, there's high chances they'll click in the button, right? And make sure a website has portrait, landscape already there as a support, because you don't know your audience. They might be using in a portrait mode or a landscape mode. One of the things interesting which I saw, we use a lot of time drag and drop. That's a feature most commonly used in the new versions of app. Find a way to also give option without drag and drop. Like have a drag and drop in your app, but also let the user also like connect or keep from one place to another place is some other way also by like clicking also, because people cannot drag till that level and drop it somewhere. It's another challenge for some people. So thinking about them, it's another way of how we can keep our apps accessible to everyone. All right, so these are a couple of important resources. You guys can take a screenshot to keep it with you. If you are thinking about making your app accessible beyond UI, you guys can have a look at this official documentation on web speed, speed synthesis, ambient light, and also you can read the accessibility pattern documentation. And there's some tools also that you can refer to that will really be helpful while you're thinking about building apps that are accessible. All right, I think we are good for now. We can have a couple of questions. Rajat? Do we have any question on this?
Hey, Tarandeep, thank you for the talk. Yeah, I have a question from my side. So how would you go about testing zero UI experiences?
Yeah, that's a very good point. Like generally for different ways, we have different tools available in the market. But for the zero UI, definitely a human person is required to interact talk through why, see how that really works. We need to put some human in the game, right? That will be able to help us, test those features. So I don't think there are ready to use tools available in the market. If I might be wrong. But what I feel is a human person is required to give it a test, try out these features, how really it works for the end user, and then we can adopt into our in our applications.
Great. Because I was also thinking like React testing library, I think its whole selling point is that it does what it tests the user interaction. So maybe
Correct.
it also might have something for accessibility also, but I'm not sure. So maybe we can look into that.
Yeah, for screen readers, there are plenty of apps there which can do a testing for us. But like thinking about Zero UI, I think it's more of like we have to go ourselves and figure out how this really works for our end users.
Okay.
So, yeah, that is something we need to give it.
Yeah. So thank you, Tarandeep, once again for joining us. And audience, please reach out to Tarandeep on LinkedIn.
Yeah, sure.
Yeah.
Definitely. If you have any question, feel free to reach out to me on LinkedIn. I'm happy to answer or talk more about this. Again, we have half an hour, so we couldn't go much deeper, but happy to discuss more on accessibility.
All right. Thank you once again, Tarandeep.
Thank you so much. Thank you, everyone.
All right. Our next speaker is Yash Verma. Yash Verma is a software engineer and a researcher who is very passionate about observability, performance, and distributed systems. He is here to talk about redefining observability for React and Node.js applications with OpenTelemetry. All right, Yash, please take it away.
Well, thank you for the warm welcome. I hope you all are enjoying your session so far for the React India conference. Okay, so let's get started. As mentioned, this talk is titled as Redefining Observability for our React and Node.js applications with OpenTelemetry. Hi everyone, my name is Yash Verma. I'm a software engineer and I usually work around the field of observability. I'm also one of the contributors to the project and I usually advocate for this OpenTelemetry stuff. So before moving on, that's my Ty, that's my dog, his name is Ty, and hi from him also. So before moving on, a few things to keep in mind that this talk is primarily about promoting observability and in the inclusion of the open standards into their workflow so that it will help you to make most out of your systems and understand when something went wrong, at the unexpected hour of that. So I will not be suggesting any particular tool or that, but by the end of this talk, you will have an understanding of what exactly this topic is and how you can figure out which tool is best fitted for your use cases, depending upon your business requirements. So let's rest assured, let's get started. Today's agenda for the talk is divided into 4 parts. The first part is we'll learn about brief history or the evolution, you will say, about the observability we know today. Then we will talk about some core telemetry signals like logs, metrics, and traces, what they are, particularly focusing on the distributed tracing part. Then we will move upon to the understanding the problem statement and then why we have this project called OpenTelemetry, what is the use case and what is the vision for this. Finally, we'll have React plus Node code demonstration as well, so you have a better understanding of how you can implement as well. So, the first question which you should be asking yourself is, what is this observability thing? I haven't heard this before. Well, maybe some of you might have heard this, but not exactly sure what is this. Some of you haven't heard this at all because this is the topic that is usually not talked in the React ecosystem, I would say. And some of you have this thing like, hey, this thing must be only about the backend kind of stuff. So why this is even front end? So is this even front end relevant topic? I say yes. So imagine the situation. When was the last time when you saw a system crashes at your workplace and everything falls apart? We started with things like error monitoring, like error reporting. We see a bunch of colorful dashboards, mostly red, I would say, and they have a bunch of Slack notifications. Engineering team waking up at 2 or 3 a.m. to see what happened. They then began the process of the root cause analysis. And after that, 1 hour into the process, no one have a clear understanding what actually happened. Sometimes, no one knows what happened, but something is happening that breaks up this entire system. So what is this observability? That's the problem statement, I would say. Now, how you can define observability is like there is no one particular definition for that, but this is how I understand observability in a more simpler way. It's about getting visibility into a system. It's about the ability to ask questions with the system and getting certain answer through the from the different telemetry signals. Questions like as this session is primarily on the React side and I would say the JavaScript specific side. So let's take an example that you are having an e-commerce application. You're running an e-commerce application. Then the question should be like, why is the payment or the checkout service slows down at certain time of the day? A more thing like things like why are some group of people unable to add product to their cart? And some things like why does the app sometimes crashes when if you're watching like any cricket match, I would say. Things like why does the app crashes sometime when Dhoni comes to bat? Or question like why is my backend service working but somehow front end is not responding, and when the number of live viewers crosses a certain threshold, system breaks apart. Maybe the sound goes off, or maybe the play button does not work properly, or you want to pause something, it does not work. Those are the things. So to answer these questions, we have different signals, right? We take the use of different signals like logs, metric, traces, and few others as well. But for the part of this topic, we will particularly focusing on these three things. So let's talk about a little bit of history from where we started. Earlier, back in the early days, applications were used to be a pretty much simple, a basic front end, with no animations and all different stuff. Just a simple text and the links to the different, where the points around there. So we have a basic front end part, and we have a certain amount of decent back end, which calls the DB or maybe something else, or like some network related things into the backend side of thing. So back then, it was very simpler to monitor those things, and the basic part and the most common way to monitor those systems were in the form of metrics, because metrics were cheaper to store and they are everything back then. Then we have a metric like these are the forms of these are in the form of lines, colorful graphs, numbers, like things like is my CPU spikes at this time, what is the storage left in there into the database, I would say, like all different stuff, the basic stuff which used to happen earlier. So then something happened. We moved on to the around 2010, when we began to move around with the distributed systems, I would say. We began to develop things in the very distributed way, like the front end has something else, and sometimes the DB are not at the same place also. So around that time, Facebook was this company that was reaching more than a million users. More than a million of users were onboarding onto their platform at some time. So they began to hit a performance overhead sometimes. So because imagine that if millions of users were trying to chat with their friends or post their pictures or their ideas to the entire world, it would be a massive scale back then, and it's hard to manage. So Facebook internally built a tool which I think requires a special mention over here. It's called Scuba. Facebook Scuba is an in-memory real-time analytics system designed to ingest millions of event rows per second and allow a fast ad hoc over the recent data, which they call wide events. So wide events are basically a single record which contain many contextual data field. Rather than just a minimal key value pair, they have the entire thing. The idea is to record things like the every possible data that they could, like from the much relevant metadatas, like events, that logs, events, and all different stuff around there, so that when something happens, we would be able to downstream we would be able to query those information and have a slice, filter, or aggregate across many dimensions without needing to join us to the other table of the part, right? So these are the things which happen around there. If you want to really read about the Scuba project, these are the few links which you can refer, and also you would be able to interestingly know about what is Scuba. So what Facebook was doing back then is not at all observability, I would say, because observability was not a term back then. But right now we can say that that was the seed of observability was planted somehow within the organization. And fast forward, by 2012 or 2014, right, we began the era of logging at scale, because we know that we started collecting every logs out there. We tried to make some analytics operation upon that, understanding the data from where they source, what is the possible use cases of the data, and it was very helpful to find the root cause analysis with the logs itself. So by 2016 or 2017, the industry started talking about the concept of distributed tracing. So because distributed tracing is started talking about those things, because right now applications are completely built in the browser. They have a much interactive interfaces. They have a much many points that they could many failure points that they could be able to stop the entire system. So in fact, the entire application was built in the browser itself, and the architecture we know was too much complex. One service was talking to multiple other services at the same time. The DB is talking to the front end, the back end part, and all different stuff. So things began to become very complex. So as most of us know what are logs and metric, so let's directly understand what is this distributed tracing, which is a fairly new topic for everyone out there. So distributed tracing, if I have to understand this thing, I would say it's a transaction which we see as a user of the which we see. Let's suppose if I have logged into a platform. So when I logged in, it will start it will have some information about me, that when I started logging, how much time did I took to authenticate myself, how much time did that service took to respond back to my request about there. Then things move on. As I move forward, let's say I added a product to a cart service, like, so how much time did the service took to add product to the cart? Then how much time is the service took to call different APIs upon that, like all different stuff. How much time did it took me to check out from the cart? The payment service, how much time did I receive the email notification that, hey, my order has been placed? So this entire transaction, when summed together, it calls a distributed trace. It gives you an idea that how your request is traveling from one place to another endpoint, right? So distributed tracing, if I have to say, what is that? So distributed tracing is made up of number of spans. So spans are the building block of a trace that represents any activity during a code execution or any associated user interaction that triggers any operation. So a span contains span name ID, trace ID, parent span ID, operation name, operation start and time, different I would say tags and attributes. They have a log attached to that, log information around there, and like really other information that are possible. These spans have these spans have there. So if you haven't seen a span before, so this is how a sample span looks like, right? So that's okay, we have spans now. Then we have to understand the thinking that how is this span working with each other? How are different services, or I would say different processes, get to know that, hey, this request is from this parent, which has to be carried upon this child, and then move forward. So the process which enables it is called context propagation. It's a mechanism that defines how a trace should be propagating between the two services, or a processes using the HTTP header or the other communication protocol as needed. So like by 2017 or 16, there were two competing standards, which talks about the distributed tracing and the metric thing, because back then the market was overpopulated with different kind of vendors with their proprietary solutions, which have the entire ecosystem was confined and are very closed, so that if I choose another vendor in the future, if I want to move with other vendors, it's very hard. I have to start from scratch. So there were these two competing standards like open census and open tracing, which were competing against each other to have understanding and a common standard of tracing and metric data, right? Because back then context was everything, and people were fighting for context. But most of the context provider, like the vendors, which we call, most of them were building their own proprietary solutions. So when we look at today's scenario, the current state of how we get visibility into our system is quite distributed as well. We have tool A, we have another tool B, tool C, and the list goes on. Then we have the signals of how we understand those, the behavior of our system using the data like metric, trace, logs, profiling, real user monitoring, events, session replays, event, error monitoring, exception monitoring, and all different stuff. So there's a whole lot of tools and a whole lot of signals out there to watch upon. So all these things create a vendor lock-in. So a user who uses these tools and signals are tied to that particular vendor. So if in the future they choose to migrate, or their specific solutions are not met by the vendor, what they should do? They should choose another vendor, but at what cost? They should have to build everything from the scratch, whatever they have built in the past. So that was a really pain point for everyone out there. So the two community, that is the open census and open tracing, decided to merge together into something called open telemetry. So right now open telemetry is under the umbrella of the CNCF, under the Apache 2 license, and all different stuff. So there should be a question in your mind, that what is this open telemetry, right? Is this a programming language? Is this another observability tool, or what exactly is this? So open telemetry at its core it's a protocol. It's how we define data formats from generation to sending data from the application to the observability backend. OpenTelemetry is a set of APIs, SDKs, and tools that helps us to create telemetry data in a vendor and a tool agnostic way. At the moment, it supports multiple languages, and JavaScript is one of them. If we talk about the influence of where OpenTelemetry lies, so OpenTelemetry basically lies into the first instrumentation part, and how we collect data and transmit data to the backend. So it's not an observability backend that helps you monitor or observe your system and what is happening wrong, but instead it's a way of how you define data, how you connect data points with one point to the another point to understand a holistic picture upon what is happening, but it will not give you out of the box visualization and all different stuff. For that, you have to use a vendor backend. So there was important concept like OpenTelemetry collector. So it sits around it sits as a, I would say, a proxy between the application and the vendor backend. So it's in somewhere middle, I would say, that is used to receive, process, and export data to the desired backend. It has the multiple receivers like OTLP, which is a native OpenTelemetry protocol language that OpenTelemetry understands. Then they have a Jaeger, which is another distributed tracing backend. When we have a Prometheus and all different stuff. So this is all about the basic stuff. What is OpenTelemetry collector? From there, we have to send data to the backend, export the data to the backend. So now let's get into the real part, setting up the OpenTelemetry for our React application. The first step in the process is like package installation. It's a simple thing which you have like whatever package you need, you just install those things like around there. Then depending upon the use cases, you may add some more or remove some of the other things from here itself. Step 2 is like creating hold on, where's the step 2? I guess my slides are not available. Okay, yeah, got it. Okay, so step 2 is about how you can create the configuration file. So it's the first step. You have to create a configuration file named as telemetry.js, so that which has informations like where you import the data, where you import everything like which is required. Then you start up a trace provider, which starts the process of distributed tracing through the spans. You can basically create and configure OTLP exporter that updates with your own collector endpoint. Usually the collector endpoint is 4318, whatever backend you are using around there. And then you can register, then you can batch span processor for better performance and register a provider if you want as well. So you can also ignore some of the URLs from being instrumented if you not really want to, and you can also propagate all these URL to the desired backend if required. So this is how to create a configuration file. Now moving on to the step 3 is how to initialize the OpenTelemetry application within your application. So it's pretty much simple process which we all have been doing from a long time. It's just the normal initialization, and this line only, the setup OpenTelemetry, will do most of the thing for itself, right? Now moving on to step 4, if we want to create a custom span component. Let's say if I want to particularly focus on a particular span, let's say we have a group of premium users, right? So we should ensure that our premium user gets most of our services in a more efficient way. So we should ask a question like, are we really having a problem with this particular line? Like we can say things like whenever we can mount a component upon that towards any activity from our premium users, and then and then when the operation goes on, we can basically end the operations as well with the span.end return, right? Whether it's like any feature you want to specifically monitor, the payment services around there, or any particular data point which you want to monitor as well. So you can have this understanding of how you are getting there as well. So, but before doing this thing, the thing like the creating a custom span component, always be careful while creating any custom thing. You must ask yourself a few questions, right? Questions like why we need to instrument these things, what should we instrument and how much should we instrument, because it basically, if you instrument too much, if you instrument unnecessarily anytime, anywhere, it will cost you at some place of time. So whether you have to think around that thing, whether it's a return, whether you are getting the ROI upon there. If you are spending, let's say if you are spending around $10, so are you getting that $100 of benefits from that instrumentation So if that's the case, then go on, please. And sometimes I've also seen people like they used to over-instrument. They used to instrument everything, and they have a huge data which has no context upon there. Like logs are separating apart, metric data flying apart, tracing data. No one knows what exactly is the outcome for that metric data and why even that folk implemented those tracing upon some use cases which is not even required, right? So that's the thing. You should be always careful about what you are instrumenting at some place of time. It's all about the business values. If you're not getting the business values, there's no need to do that thing as well. So yes, all the same. The next part is like getting the required metrics from your React application. We have done about the tracing part. Now it's the metrics part, right? So how you can get the metric? So things like how you can keep a watch on the React render, how it is performing around there. So it's basically around you can just like record the mount. You can just record any activities if mounted around there. You can record like anything mounted, like some activities which you want to particularly focus on around there, and then render your process data in the desired format, I would say. So this is pretty kind of basic stuff, I would say. The code itself is self-explanatory at some time. Just have the basic definition or the schema, I would say, that has to be understood if you are the first time user of the React. Now moving on with you can also do something like tracking a user specific interaction, I would say. Like, so you can create a span for the search operation. You can use context API to bind the present context. You can do something like you can like any async operation started will have a parent span upon that thing. So you can attach everything upon a particular user interaction as well. So whether a particular user is going to check out, and like any basic details, basic definition of if you want to understand this user interaction as well at any place of time. So these functions will automatically create a child span because it has a fetch instrumentation, as we have said earlier for this. That's the, I would say, this is also possible that how you can connect the front end and the back end traces of your two different services with OpenTelemetry as well. So I guess this is somewhere around close to what is some end-to-end observability exactly is. Since there are many development that needs to be done into this field, there are many tools out there that calls around end-to-end observability, but very few of them which I have used able to deliver upon these words, because end-to-end observability is a very vast topic. So we have to understand that what is this really end-to-end means. So by using the OpenTelemetry APIs at present, it's not a completely end-to-end the solution, but I would say it's somewhere around close to the end-to-end, right? So with that, you can connect the front end and the back end through the OpenTelemetry itself. So this can be implemented through the OpenTelemetry API, like the propagating the trace context through it, right? So you can do something like add the current trace context in this header, and which will carry the information from the header itself, and which will be if there is some error, it will check for that. Further on, it will pass on those information to the spans with the same parent ID will be able to interact with those things and pass information from there. So this is how a basic setup looks like, where you want to provide context from like different services around there, particularly about the front end and the back end side of stuff. So this is how you can make those things happen in real life. However, there is this one important concept in OpenTelemetry. It's called semantic conventions. It basically have a set of rules to how should we name a particular thing. Let's say a request came from payment service through HTTP, right? So how you can define that? How you can name that request? Either you can say that HTTP payment, or you can say payment HTTP, or you can say something like payment.http, or http.payment, or http.payment.premium user, whatever you want to say. So we have been facing this problem usually within the same company when we are in different groups, or let's say you change the company and you just want to understand the code base. So first you have to understand how does that company name a particular thing. Although things are pretty much similar, but somehow there are some small details which you have to look apart, right? So this problem is solved by the semantic conventions in OpenTelemetry, which gives us the power to generalize a particular name, which have a set of widely adopted naming standards for that a particular thing. So if a request coming from payment through HTTP from a premium user, it would be called as HTTP, let's say http.payments.premium user. So throughout the entire system, that naming convention would be followed. So when we try to debug the issue somewhere, when an incident happened, that particular thing would will work as an advantage for us, because we would be easily able to understand what is the source of the request, where it might fail sometime in the middle, and all the basic stuff and all the related stuff behind that thing. So this is a very interesting thing. So we have a naming convention for our traces data, for our metric data, for our logs and other related data. Let's say for the DB, or for any other related stuff. So let's bring to the end of this talk. The vision for this talk was not about how you can empower or how to tell you a story about yet another tool, but to introduce you to the open standard way of doing things, how we observe things, how we implement those practices into action within our React application, whether it is from creating your first span, or creating your specifically tailored, I would say, a custom span for a particular user, or any other thing you can say that. So this talk is not the guide, but this talk definitely give you an idea how open standard works around there when it comes to the React ecosystem around there. So yeah, that's all from this talk. I hope you enjoyed this talk. I know it would be pretty much, if you come from a very basic JavaScript kind of thing, it might be not a way, because some people who just started might feel that, hey, this is overwhelming, because from the day one, performance has not been their priority for many of the starters as well. But with time, when you go up, you realize that, hey, adopting to open standards and gives us the power to have the control of our data in our own hand, so that no vendor would be able to control our data, what should be monitored, what data should be sent there. So all this thing has to be in your control, because it's your data, right? So you have to be in charge of your data. You have to be responsible for everything data you work on around there. So that's all from my side. If you want to get involved in the OpenTelemetry ecosystem, these are some few links which you can refer. We have a weekly meeting, so where you can come around and see what is happening around the ecosystem as well. So yeah, thank you for joining me for the talk. That's all.
Thank you, Yash. Unfortunately, we are a bit over time, so we won't have any, we won't be able to do any Q&A. I'll quickly jump to the next speaker. That's Navya Agarwal. Navya is a senior software engineer at Adobe, or is it Adobe? Navya? I always wonder.
Adobe.
Adobe. Okay. So Navya, she works at Adobe and she explores front end and JavaScript frameworks. And she's a coffee enthusiast like me. Navya, what's your favorite brew?
It's medium roast.
Medium roast.
Always.
Any particular brand?
I am Chakoi. Blue Chakoi is suddenly my favorite. It's becoming one of my favorite brands right now. Is it yours too?
Yeah. Is it available in
Oh,
I didn't know.
no, I always carry my stock whenever I'm visiting India. So
I'll make sure to keep a big pack ready for you when you come to India.
Perfect.
Yeah.
Thank you, Raji.
Yeah. So let's get on to this talk. Are design systems ready for AI revolution? All right.
Thank you. I'll start sharing my screen. Great. I hope my screen is visible. Rajat, can you give me a thumbs up?
Yeah, it's visible.
Perfect. Okay. And it's moving as well. Great. Okay. Let's begin. Good evening, everyone. I'm really excited and honored to be here. And thank you for joining us in from wherever in the world you are joining us. Great. Let's jump in since we are a bit late for the event. So we'll just directly jump to the topic and not have any small talks. So on your screens right now, you must be seeing some icons for the next 4 or 5 slides. And I want you guys to just think about what these icons mean to you. Maybe a floppy disk for this one. How about this one? Maybe a download button. This might seem similar to a bookmark icon that we generally see, right? And this is the normal save button. To be honest, all these buttons that you just saw or all these icons that you just saw meant a save button. Now imagine that you are moving between apps all day, and every time you need to save something, you are stopping to think, wait, is this the right save button or is this a bookmark button? It's total chaos, right? And that's when it hits someone that this can't go on. Long time ago, far, far away, some tech enthusiasts decided we need a design system for UI components. Their mission was so simple: to design the ultimate button. This button would have it all. It wasn't a simple button. It had to be a chameleon, adopting to all forms and functions. They began with a basic button, a button with a text, right? As you see on your screen. A button with a text and an icon. A button with a text and some SVG icon. Or maybe just a simple icon. It, of course, had variants. It had a primary variant. It had a secondary variant. It had a danger variant. Sizes, of course. It had a small size, a medium size, a large size, extra large size. State, of course. It had hover state, it had selected state, it had focus state. It used to have a dark theme, it used to have a light theme. It worked for any text lens and had internationalization baked in. It would work on mobile, it would work on desktop apps, it would work on native iOS, Android. It was accessible. This button had it all, and it was ready to go. And just when it was ready to go, a new VP comes in, and he had heard about design systems, and he wanted a new one for his organization. he said this design system would be even better. So the team started building a new button component yet again. The cycle continued, and everyone on the team, from the designer to the developer to the quality engineer, wondered how many times in our entire career we will be designing / coding / testing a button component, designing buttons over and over and over and over and over and over again. But while we were stuck in this loop, the world of design systems was quietly growing us around us. A lot happened to design systems between 2015 to 2022. And a lot of you who are watching this video or might be watching the live stream later are responsible for this change, from writing articles to tweeting about design systems and posting on your portfolios. Between 2015 and 2022, we saw a boom. Every company wanted a design system. But today, these design systems might be in any of the two states. Number one, where significant effort went into those Figma libraries, architecture, and components, but no one really uses them. And everyone prefers to do their own thing. A sad, desolate place. I call it the design system ghost town. And second might be where teams were moving so fast that design systems never stood a chance. A place even more desolate and desperate. I call it the design systems graveyard. So while design systems were either sitting in ghost towns or were buried in graveyards, the world around us was slowly, quietly building something completely different. Where were you all guys on the biggest day in history, November 30, 2022, when this guy tweeted about ChatGPT? I remember seeing this, seeing the first tweets and chats about this AI. And to be honest, it freaked me out a little bit. And my crypto friends were like, is there an NFT of this that we can buy and invest in? I tried this fascinating thing called AI. I remember giving it some of the crazy prompts like, generate an image of a cat celebrating its birthday. And it gave me some image with a cat of wearing a birthday cap and cutting a cake and whatnot. And I had a big laugh. And I was like, is this the big AI revolution that we are talking about? And would it do something different rather than just being creative or writing those beautiful emails or those Slack messages? And fast forward to 2025, AI has entered the room and it is here to stay. It has entered the design system world as well. It can help us design systems, the workflows, the components stay alive, relevant, and actually used, saving us from the desolate fate of those ghost town or graveyards. And now we have something that we call as AI-driven design systems, which brings me to the talk of today. Are design systems ready for the AI revolution? But first, hi, Rajat has already introduced me, but something just about myself. I am Navya Agrawal, a senior software developer at Adobe. I am also an active member of the W3C Council and the ICC Council. Great. So today we will be doing a quick demo and navigating the pitfalls and wins along the way. Since React India's in-person event is hosted in Goa, and hopefully all you guys are attending the in-person event as well, I bet it would be as amazing as this remote day. So I thought, why not to combine two beautiful things that Goa clearly enjoys, right? First is the beer thing, and the second is riding your bike or car, which is why today we will be building a beerometer. Okay. So what I will be doing over here is I will be quickly going to my IDE and telling it to help me design a landing page for a barometer. And since we're talking about design systems, I tell my ID or my cursor to think about all the compliance models and all the governance models. And you can see this long prompt that I just wrote to feed my ID, talking about the button component and the thumbnail component, as well as my design systems requirements, be it accessibility, be it token enforcement, be it respecting my design system library that we use. And you can see the output on your screen that it gave me a long list of design systems token. It gave me a button component, that's the reusable component that we are building. It also gave me a button.css file, respecting my design token system. And the second reusable component that we are building today is a thumbnail component. So it also gave me the code for my thumbnail.ts as well as the CSS file related to that thumbnail component. Great. So and it also beautifully tells me that I'm respecting all the accessibility features, following the YCAG guidelines. It also tells me that I'm respecting your design tokens and your design library. Awesome. Things are looking good so far. Amazing. Now let's just do a quick test. So this is the final result that I get from my ID, and let's just play it. So we have a heading component, we have a button component, which is add pair, and we have two buttons, add pair and remove pair. And as you can see, when I'm clicking on add pair or remove pair, the thumbnail component is also changing with that smiley emoticon and telling me whether I'm tipsy or I'm in a sober state. Okay, this demo really had me. What AI got right. It had a beautiful visual design and gradients and animation. We saw that tipsy thing, the emoticon giving us all that. We also had the proper TypeScript interfaces and the prop handling. We could see multiple variants of the button component. We had a danger button, and we also have a primary accent. We had different responsive states, including the disabled button. And when I saw the code, it was clean and modular architecture. Good. And that too, everything at a seductive speed, right? But the real question is it production ready? And that's where we will be testing this particular app out. So at my organization, at least, whenever we are creating a design system component, we have to make sure that it passes our compliance model. Things like accessibility, like be it keyboard navigation, voiceover support, color contrast, and more. We need to make sure that the design is around centered humans. It should be inclusive. It should be designed for all. And of course, every organization needs to follow its privacy and data security, make sure that the design system component or the app that you are designing doesn't have any effect on XSS scripts injection, etc. So let's put it to test one by one. Okay, so I now will be turning my voiceover on Mac on to see how this particular app or particular components behave when I have my voiceover on, so that to see whether all the attributes and all the components are announced clearly on the screen and how it would look to someone who is visually impaired. Okay, let's give it a check.
Chrome, Byte plus React plus TS. Entering Byte plus React plus TS web content. Add beer, button, main. You are currently on a button. To click this button, press Control, Option, Space. Leaving Byte plus React plus TS. Entering leaving toolbar item palette. Entering Byte plus React plus TS web content. Add beer, button, main. You are currently on a button. To click this button, press Control, Option, Space. Remove beer, button. You are currently on a button. To click this button, press Control, Option, Space. Shift, off. You are currently on a button. To click this button, press Control, Option, Space. Remove beer button. You are currently on a button. To click this button, press Control, Option, Space.
Great. So if you saw this demo, it did a good job, but not a good job as well, I would say. So it did announce the buttons, add bear and remove bear, but it did not tell me anything about my thumbnail component. It didn't tell me whether the state is being changed or any alive attribute is being added to the thumbnail component. Secondly, if you did notice, when there were 0 bears on the thumbnail, the remove bear button was disabled and only the add bear button was enabled. On that note as well, the voiceover didn't announce that there is a disabled state of a button. And so imagine someone who is visually impaired, he would just feel that there is a add bear button at that moment. And he would not know that there is a thumbnail that is also responding to whenever he's adding or subtracting anything from that entire application. So I would say the entire test that we just did with our design system components didn't do a fairly good job and it failed. Okay, so accessibility failed. Let's see how the voiceover failed at least. Now let's see the second test. So over here, I'm using my Wave plugin to check the color contrast and see how it would look to someone who is visually impaired. So as you can see in the Wave plugin on the left-hand side of your screen, it says that it has very low contrast. Okay. It is also telling me that for structure elements, which is okay, good that I have a heading level, at least we are using the right semantics for over here. It is also telling me the different order in which these buttons will be navigated. And as you can see, only the add bear had a one label. The thumbnail component or the remove bear didn't have any order of the elements. And you can also see that it failed in the YCAG AA and AAA guidelines when it comes to color contrast. So even though I had told my ID or my cursor ID that, follow all the YCAG guidelines and make sure that it doesn't fail the color contrast test, but while actually putting this particular component to test, it failed. Okay, now let's have a look at the third test. So over here, I'm trying to inject a XSS script. Okay, and now let's see what happens. Oops. So as soon as, so I had put in my code that whenever the bear count is more than 7, XSS injection should happen. And unfortunately, the design system component that was developed by the ID couldn't take it, and it again failed terribly. So yes, it did generate some really, really fast code. But what is important, that it didn't generate good design systems code really, really fast. And this is my favorite meme whenever I'm talking about that expectations versus reality thing. This particular demo had an initial wow factor, but very few compliance check marks. And this is exactly what I call as the inflated expectations. This meme is funny, but it makes a serious point. AI can look impressive, but without guidance, it can miss the mark. All right, so now we have seen that what AI can do and what AI can't, but the big question is, how can AI actually meaningfully integrate with design systems? Design systems aren't just pretty buttons and colors. They're about consistency and constraints and human-centered design. AI can help, but only if it respects those rules. Great. So my first tip on how we can integrate AI with design systems would be guardrails. Design systems love guardrails. And that's the big idea with them. So we are basically saying that we don't want a button to have any color from the 1.6 million hex codes that are available, but pick from those crafted 20 colors that my organization follows. Don't pick the size from, let's say, where S can mean 10 pixel or 20 pixel, but pick from our spacing tokens where S means that it would have a particular spacing token assigned to it, and it would behave in the same way across devices. Basically, by putting these limitations, we are creating consistency in design systems. And that's what the crucial piece is, to have those guardrails. AI loves guardrails too. And it's the classic garbage in, garbage out problem. We saw in the demo when I asked my agent to create a beautiful, nice landing page with blah components, the thumbnail component and the button component. But also at the same time, we saw problems that we just talked about. The agent just picked a color from the 16 million hex codes that are available. So yes, the demo did work, but it failed a lot of compliance checks. So telling the model about the constraint will surely land us in a better position. It's like you're giving the AI or your tool a high quality input and you get a high quality output. Okay. My next tip, how we can use AI with design systems, would be to scale the existing design systems. And AI does a pretty good job at it. AI can help you in expanding the design systems by generating variants or themes or localization automatically. So maybe you already have written code for an extra small or a medium and a large button, and you want to add an extra large button. Maybe you have code for a primary, secondary, or a tertiary variant, and you want to add a danger variant. Since you have the expert design system code already laid out and written for you, it's kind of an easy thing now for the AI machine to simply follow the rules and expand on top of it. And this will save a lot of time by writing the machine the new API and making sure that all the compilations are also in place. So for example, if you have, let's say, 4 variants, 4 sizes, and 2 states, which is 4 into 4 into 2, which is 32, to manually create and write test cases for these 32 combinations, it's a tedious job. And that job is something that we can ask the AI to generate me the test code for all these 32 variants with the proper documentation and edge cases that you must have forgotten about. Okay, moving to the third tip. We can easily and beautifully use to ask the AI agent to do that mundane job. AI can help you writing those documentation updates, the do's and the don'ts guidelines that you define a new component or a prop. It can help you with test generation. It can also help you to automatically write those release notes that you share it with the larger organization. Another thing that AI can help when it comes to design systems is system governance and consistency. It can help you to enforce the right design tokens. Let's say you are hard coding a color of the button, for example, that you see on your screen, right? Your ID or your AI agent will monitor and see that you are deviating from the established color palettes or typography and suggest you to use the right correct token. Another thing that is very good when it comes to AI tools and design systems is component auditing. AI can scan some of your existing code and flag the inconsistencies or suggest you with actual opportunities how your code base should be structured. And third but not the least is version control intelligence. AI can track the component changes and suggest the migration paths for deprecated elements. Great. Now coming to tip 5. So we all saw how AI is good when it comes from an idea to an interface. It can, in minutes, we can go from a blank canvas to something that you can show your team and brag about it. In life, we often draw lines between what to do and what we don't want to do. And these lines are often visible between design and engineering. But in the age of AI, those lines are starting to blur and even shift. Rapid prototyping, quickly putting an idea to code, helping designs to give a more realistic representation of how an application can feel and identify. Even Brad Frost says and highlights that LLMs can generate component boiler code 40 to 90% faster when trained on your system's code base. Speed is valuable, but what is speed without intention? You are really just borrowing against the future, right? And that's where Figma MCP comes in. You can think of MCP as a USB-C for AI. So rather than forcing the AI agent to guess the design intent from the screenshot of your design system component alone, the Figma MCP acts as a bridge between the Figma designs and the agentic coding environment. Isn't writing such a long prompt that I showed you in the starting of this talk is tedious and exhausting? Some might even argue that you can write the code faster yourself rather than writing that entire long, gigantic prompt. So instead of manually coding or writing long prompts, you can leverage Figma's multi-component plugin to generate variants directly in your design. Trust your designers. They are already using the right tokens for spacing and states in Figma. So the developer can now prompt the MCP server to pull the design information from Figma and orchestrate the design, and coding agent can help you to generate it. So without the Figma MCP, the developer is left to interpret the Figma design. As you can see on your screen, if we didn't have a Figma MCP, the developer is the main source who's interpreting the Figma, as well as writing his understanding as input to the IDE, which is now generating the code for you. As opposed to with the Figma MCP, the developer connects the Figma MCP server with the Figma file, and the MCP server handles the initial interpretation and directs the coding agent to what to build and what not to do. So as you can see in the screen, that now developer's job is now just limited to fetch and look at the Figma, generate something from the Figma MCP, and now the Figma MCP and developer directly talk to the IDE, which can generate my code for me. So all you have to do is, for example, go to your Figma and enable the dev mode MCP server, and go to your MCP, go to your Figma documentation, and whatever component, a reusable component you have to develop, simply right-click on it and copy link to selection. And now our long prompt that you saw in the starting of this talk is now just reduced to one line. You can also write your own MCP server on top of Figma's MCP server and connect it to your IDE MCP client. Structuring Figma files with semantic layer names and reusable components creates the foundation of the effective MCP-driven code generation. We need to implement design variables for spacing, color, radius, typography to provide clear design tokens context that AI models can map directly to code. So now that entire long prompt can now be simply reduced to just one-liner code using Figma's MCP server. If you want to take one thing from this talk, I would say that AI can definitely save you more cycles. As you know, software development has always been a game of abstractions. If we think back, we went from transistors to CPUs, we went from computer instructions and assembly to JavaScript, and we have gone from document.getElementById to frameworks like React. So AI will perform that next step function of abstraction for you. We will still need some core principles, right? You are still going to need to understand your code base. You are still going to need to know how to debug. You are still going to need to how to write good documentation, generate unit tests, the kind of, and the list goes on and on and on. But that's what make us software developers, right? But AI with tools like Cursor or ChatGPT, it can accelerate these flows so that you don't focus on doing that boring or the mundane task. You notice, and if you notice in this analogy as well, the steering wheel is still there. And that's because you, the developer, should still be in the driver's seat, and AI is simply a companion that sits next to you. The win is humans along with AI, not humans without AI. So yes, thank you everyone. That's me on LinkedIn. Feel free to DM, and hopefully you were able to enjoy this talk and get something out of it. I'll stop sharing my screen. Off to you, Rajat.
Thank you, Navya. Personally, this talk it helped me a lot, because whenever I use Cursor to, generate some code, I feel a little guilty because I feel like I'm taking a shortcut, but your talk really helped me a little. Thank you.
I'm glad. Thank you.
I want to ask you, like, from Adobe's perspective, what early signs have you seen that AI is genuinely, improving design velocity and creativity, and not just automating things?
That's a really good question, and that's a question that everyone is asking right now, right? Whether is AI accelerating or deaccelerating? I think AI has a lot of potential, and of course, it's here to stay. So what we really need to do right now is use AI to our leverage. So as your question was, like, you cannot just simply go to AI and ask it to do the things. It will definitely not lead you to something that you will call as developer velocity is increasing. You need to make so whenever you are training, for example, even a junior developer in your team, you cannot just tell him or her to go and write a button component for me. You need to tell him or her, instruct and guide it what exactly needs to go into that button component. You need to tell him or her, or tell him about the compliance model, that this button component needs to do accessibility compliance, for example, or the entire list, right? So that is what is missing. We need to use the AI tools with a pinch of salt, I would say, and make sure that you are getting the most out of it, rather than it is using you and hallucinating. And yes, that's what I would say.
All right. Thanks once again, Navya, for joining us. I know it's pretty early at your place, so double thank you, I would say, for joining us live, that too.
Thank you.
Now, I guess Navya, you can reach out Navya on Twitter and LinkedIn for any further questions, or if you want to discuss anything. All right. Thank you, Navya. Bye. Yeah. Before we go to our next speaker, I just want to once again give a big shout out to all our sponsors, especially our gold, platinum, and silver sponsors, such as AWS, Firebase, Brevo, DE Shaw, Talentship. Talentship has been with us for a long time. They have sponsored us on our earlier edition as well. So I shouldn't say this, but double thank you, Talentship, for sticking with us. Arcesium and our bronze sponsors as well, Bronze sponsors have helped us organize our meetups that have been happening throughout the year by helping us arrange venues, and they also helped us sponsor the travel for our speakers that will be arriving at Goa at the end of this month for the in-person talks. Okay, so our next speaker, Neha Gupta, is here. Neha Gupta is a senior software engineer at Brevo. Once again, Brevo is our gold sponsor. Neha is passionate about building accessible and scalable web apps, and she is here to talk about enhancing UX through islands architecture. I mentioned islands architecture earlier, so Neha is going to build on that. Hi, Neha, how are you?
Hey Rajat, I'm doing good. How about you?
I'm good too. Very tired.
This happens. Hopefully, you will get power through my talk and everyone's talk after me. So
Talks
really
are very easy. Talks are very entertaining. They are what's keeping me awake right now.
great.
Yeah. So over to you, Neha. Take us to the islands of island architecture. Sorry for the bad joke.
No worries. Cool. I'll share my screen. Okay. Hi, everyone. As Rajat mentioned, I'm Neha. So today I'll be talking deeply about how to enhance your user experience through island architecture. I'll just close this one. Yeah. So basically, we'll be discussing how to move from server components to smart islands, and we'll be discussing how to make your application more, performant, more smarter, and more faster. So coming to my slide, so I'm Neha. I work at Brevo as a senior front-end engineer, and I'm really passionate about accessibility and building scalable front-end systems and learning about front-end architecture. So here are my socials. Feel free to follow me on LinkedIn and X profile. So yeah, moving to my topic. So today we'll be discussing briefly about what are the modern performance challenges that we face in our application. So as we know, performance is the core concept in our app, and every user wants performant and faster application. So how island architecture is a solution and how it provides performant website. And in this island architecture, there are few patterns. So you can't just call a particular component an island. There are methods to call those islands. So we'll be discussing more about them. Next, we'll be discussing what are the pitfalls and what are the best practices that we should keep in mind before moving onwards with this architecture. And lastly, we'll be summing up with few key takeaways. So coming to the performance challenge that we face in our application. So nowadays you may see that people are very fast. They want everything in seconds. They want swift delivery and in e-commerce website. So obviously they want a performant app as well. So how to make your application more performant? It's a really great challenge that we face nowadays. So I'll be discussing this and talking about this via a real world example. So consider a case that where you went to a shop and you want to buy something, for example, a speaker. So you go to a shop. General cases, you go to a shop and you go purchase the speaker. But you notice in shop number 1, everything is empty. There is nothing present over here, which is not good, right? There is no structure in this application. So you go ask the shopkeeper, can you please give me this product? So he present to you a product, but it's not a speaker, it's a headphone. Then you are like, can you please give me a speaker? Then he presented you with another product which is not relevant at all. Then after n number of time you are given your desired product. So yes, now structure is finally present. But what about interactivity? You want to test this product out, you want to check the configuration, you want to check how it sounds. So you ask for the testing of the speaker, or you want to interact with this particular element now. But the thing is, the shopkeeper started explaining the features of the first product, then to second product, and then again after n number of time he reaches to the nth product. So here the structure wasn't pretty good. You didn't find anything, the shelves were pretty empty at the initial. But and also the interactivity wasn't good as well. You just wanted to interact with the speaker and go home, right? But you are presented with every product and the interactivity of all the component. So how to improve this experience? So you go to shop number B. Here you notice, okay, the products are already lined up. You can see everything in the shelf. But the thing is, when you ask for the feature, the shopkeeper again tells you the features of product number 1, then to 2, then finally after n number of time, they reach to product number n. So in this case, the structure was pretty good. Everything was already present and you can go ahead and pick up the product. But the thing was, interactivity wasn't good here. So comparing both scenario number 1 and scenario number 2, you can see the structure wasn't good here and interactivity wasn't also good. So structure generally in our web page denotes the HTML. So all the content that you see in a page is our HTML and is the structure, basic blocks of our application. And all the interactivity, suppose you want to click it, you want to change the state of an application, is our JavaScript. And we call it as a hydration. So when a page is hydrated, we can interact with a particular element. So the first example is a classic way of saying it's a single page application or a client-side application. Here, everything is sent to a client in a single bundle. So initially, you will have an empty tags in your application, and all the JavaScript and HTML get sent to a client in a single bundle, which is not performant, right? Even if you want a single element in a page, everything is getting sent to you. And in the second example, the structure is basically denoting the HTML and which is present, but the interactivity wasn't present. And this is a classic example of server-side rendering. So in server-side rendering, everything gets pre-rendered in your page on the server itself, and only HTML is getting sent. JavaScript is added after it. So it is getting hydrated. All the pages getting hydrated. So this is pretty good when you use any static website like blog, but it is not good for any e-commerce or that sort of, it's good for e-commerce website. So the thing is, what if you only want interactivity but with a particular element only? So the main problem arises that most of the content is static, yet we are hydrating everything in our page. And this leads to very bad performance, and our core web vitals, mostly like time to interactivity, gets delayed, which results into delayed interactivity due to full page hydration. So in a code, it will look something like this. So when I say a client component or a client-side rendering, we generally use this directive, which is use client. This denotes that the particular component or a page is client. So I have a page with a page layout wrapper. I have few hooks present over here. And this is the hooks are present so that user can interact with a particular element. So you can see in this layout, everything is static. You don't want to, user can't change the content of a header or hero section, but they can interact with carousel. They can go to the next slide, they can go to previous slide, they can interact with it. But you notice only this component needs hydration, yet we have our hooks present over here and use client at the top. This hydrates everything. So everything gets sent as a JavaScript plus HTML bundle, which is not good at all. So we have moved beyond our single page application bloat, and we have moved beyond our server-side rendering bloat. But then we ask, what if we only hydrate what's necessary and not all the pages? This brings us to the solution, which is our main topic, islands architecture. So in islands architecture, as you can see, what can be the solution when you go to a shop? You notice the islands are already, the particular elements are already lined up, and only the component that you want to interact with, the shopkeeper only tells you the interactivity or the features of that particular product. So yes, structure is pretty good, and also it's efficient, and interactivity behavior is also good, which is a pretty win-win, right? I think it's pretty cool. So what is island architecture? So island, in here, you can see this image, like I have a sea of content. So this sea is a static component. Nothing is interactive. So generally you can relate it to like human can't live on any sea or any ocean body, but they can live on island. So this sea is not interactive. Humans are not there. It is a static content, and only island, the patches of code that are interactive are our islands. So island architecture treats interactive components as island of interactivity within a sea of static content. So here the majority is our static HTML with zero hydration required, and our minority are our interactive island. So here only selective hydration is required in these islands. So when I talk about the particular C or the majority part of it, right, it takes the majority part of our island architecture. They are essentially our RSC. So RSC are our React server components. So when I say a component that is loaded on server, so it means they only send HTML. They only send HTML or serialized data here. So as it's mentioning, it is a new paradigm that allows component to render the server to render on server and send the result to client as serialized data. No JavaScript is present over here. So when I compare it with a client component and a server-side component, as the name suggests, client component is something that is loaded on a browser. So it runs on a browser, but server component, it generally runs on a server itself. And as I say, client component, since user want to interact with any particular element on a browser, so it sends both JS and HTML. But in server components, we are only sending the particular HTML data. Now coming to the hooks, whenever I want to interact something or I want to change any state in a React application, I require hooks. So these hooks are only present on a browser or on the client components, but this is not present on a server-side component. Now coming to the backend, since user can interact with it, we don't want any hackers to take away our database or the secret keys. So yes, client components can't access anything from backend, but server components can. Lastly, as it's mentioning, like client component sends both JavaScript and HTML, so it adds JavaScript to a client, but server component sends 0 kilobytes of JavaScript to the client. So considering this island architecture into a real world example, in an e-commerce application, you may notice there are many product cards, right? So I'll test you guys' knowledge till now. So consider a product card where you have an image, where you have the product title and the prices and a description and a like button to add it in a wish list. So what all you can see the client or a user, a customer can change. So any guesses? So main thing is user can't change the image of a product. They can't change the name of a product or the price of a product. But yes, they can interact with a particular like button. So here, all the static content that user cannot change are our static C. But the component that user can interact with are our islands. So looking it into a code, in our traditional React application, how would we write this product card? So we will just use, since use client is used, this whole component is a client component, and I have a state to toggle through my like button or adding or removing it from a wish list, and I have my product card with the name, price, and images mentioned over here. So entire component and its dependency gets shipped to the client. Whereas in RSC, the main paradigm is we have a product card, but yes, you notice this is a server component. We don't have any use client directive present over here, only the component that requires hydration. So in this example, we notice only the like button requires the hydration. This product, this particular line, this particular component is decoupled from our main card and added as a new component. So only this like button gets the use client directive and has the interactivity of hooks, whereas the product card is all static present over here. So only interactive button gets shipped to the client. This reduces the load as well. Since this product card is loaded on a server and sends as the HTML, only like button is getting sent with HTML plus JavaScript. So what is this RSC and what's the impact of this RSC? So before using RSC, generally everything like JS is also getting shipped to the client, but with RSC, only HTML gets shipped to the client. So yes, it reduces the bundle size of our application. And what is like in data fetching? So this product card, generally when we started learning about React, you remember we used Axios or fetch to fetch any data, but these Axios or fetch, they fetch the data on client side, and you can see the call being made on the network tabs. But the main thing is before RSC, it will be visible to the user on client side, but with RSC, it is loaded on a server and user can't see the network call. So it results in faster initial loading. And since it's rendered on a server, it's good for SEO as well. So any web crawlers or robots, they can check your website and link, so the potential clients or potential customer can reach to your site efficiently. So yes, before RSC, hydration is required, but with RSC, it's already pre-rendered. So yes, it results into better indexing. For security, since we are calling the API on client, the API keys are exported, and it may lead to site getting hacked or someone may misuse it. But with RSC, it's only called on server, so it's more secure. So yes, RSC never hydrates. They produce 0 client-side JavaScript. So finally, our whole C, the RSC and our islands are a perfect match. So RSC, they are like the static content on a page, or client-side components are the hydration. So the example that I mentioned earlier for the page layout component, this is a server component now. Earlier, it was client component and everything was getting hydrated. Now, our layout is not hydrated at all. Header section is removed, hero is removed. Now only carousel island, as you can see, is our island, and this is getting hydrated with HTML and JavaScript. And if you want to call any scripts for any interactivity for GTM, you can create another island at the top level. So this removes the concern of too much dependency between two components of interactivity and normal static components. Now coming to the island patterns, we talked about RSC a lot, but what about islands, right? We can't just dump all the islands at one go, because this will also bloat our app, because they are loaded on a client and they can result into much more bloated application. To resolve this, we have our patterns present over here. But why are these patterns that much efficient? What's the need? So in a web page or any application that you may see, there might be few components that you want to use later on, don't want to use them on the initial load itself. And secondly, there might be few components that you don't want to see in the initial load as well. You just want to check them after I click a button or if I scroll through them. So they are also not required. And also there might be few components that are not in the UI. So if any component is present at the bottom, I don't want to call them at the first load. So that's why island patterns are really useful for us. So coming to the first pattern, which is our lazy island. So yes, lazy suggest they are lazy. So basically they just come up when you call them, right? So they just load our JavaScript when user interacts with them. So as you can see, I have a phone over here and which is having a button. So this island will only get calls when I interact with it. So how can I interact with it? I can either, click on it. So whenever I click on a particular button, the particular island gets loaded. So how will this example look in a code? So since this is a island which is lazy, so we will be using dynamic import. So dynamic import are basically called to used to not call a particular island in an initial load. So this search island is present over here, and I have a use state or a hook to toggle between the state of showing the island or hiding the island. In an header, I have a button to change the state of a particular state to show or hide the particular island. So step one is whenever user clicks on a particular island, the use state, the toggle state will work, and the particular island will be visible to a user. This is pretty quick and efficient way to offload the unwanted JavaScript from your page. So I have a demo present over here. So as you can see, I have a button which is having a search icon over here. So I don't want to call my search bar in the initial load. I just want to call it when I click on a particular button. So here, no JavaScript is present in an initial load. Whenever I click on the particular button, you can notice the particular search island is called and the search bar is available. This reduces, the paradigm for calling my unwanted search island in an initial load. So yeah, why this pattern actually matters? So yes, first thing that we talked about since the beginning is the performance. Yes, it avoids loading the search island on initial load. It only loads it when it's required. Secondly, it increases the modularity and scalability of an application. So it's useful when features are heavier on JS or when they are interactive. Lastly, this example is pretty great for any modals or search bars or chat UIs that you may have in an application. Now coming to our second pattern, which is intersection observer pattern. So intersection observer basically have a viewport. So you can see in this image, I have a red line which denotes a viewport. So viewport is generally something you are watching this presentation on a laptop or might be on a mobile. So whatever you see on your screen is a viewport. So consider this green rectangle as my device. So whatever is present in this red line is my viewport. And we are loading, so this pattern generally denotes we are loading only those components that are present in our viewport. So you can see there are 4 components present initially. First, second, and third are touching my viewport line. And last component is not touching my viewport line. So these 3 components are loaded content, and last content is my load more content. Whenever user scrolls, so this element should come in third place. So whenever user scrolls through the viewport, they will notice the island is getting loaded in the JavaScript in a client browser. So looking at the code, how will this look? So yes, since it's an island, it will have a use client directive present at the top. Also, it will have some use state to use to change the state of a particular island to how to load it. So first step will be whenever user sees an element in a viewport. So we use intersection observer to replicate this behavior. So I have a ref present on a div, which is present over here. And I also have a state for is visible and set is visible. Whenever the element is intersecting, I'm changing the state to true. So whenever this state becomes true, yes, this island is loaded in a viewport whenever the condition is met. So I have an example of this as well. So yes, so you can see the page length is too long. So whenever user scrolls through this page, you can see the particular interactive carousel island is loaded over here. I'll go back and show you again. So yes, initially it's not loaded. Whenever user scrolls through it, the particular island gets loaded. And I've also added the lazy island in this example. So carousel can also use lazy island here as well. So yes, you can see in the interactive carousel, all the JavaScript gets sent. So in this, see, whenever I click on second element, the particular slide 2 is getting loaded. So this is lazy. It only loads when user interact or clicks with it. So when I click on third slide, this third slide will get loaded to a particular browser. So why this pattern matters? So yes, the feature is smart hydration. We don't waste our JavaScript on component that user may never see. So consider any e-commerce application where you have thousands of products. You don't want to call all the products. You just want to call the top priority or the products that user are seeing. So we don't want to waste our JavaScript on the products that are present at the very last of component. Second is fast load. So it only shows static previews initially. So here you can see when the island was not loaded, I have a static carousel preview present over here. So you can also have a static content present to show initially. So this can help in, not reducing the CLS of our pages. So and third will be the smarter initial bundle. So full carousel JS is loaded on demand, but not initially. Lastly, since we are using intersection observer in our pages, so this intersection observer is loaded only once and not every time when you load this page. So no performance overhead after it's loaded. So this island is particularly good whenever you want to hide anything when user sees a particular element. For example, carousel, widget, product cards, and there are n number of examples for this. Now coming to our last pattern, which is prefetching island. So in this one, I have a mobile device present over here. So you can call any website like brevo.com or any example you have. In this example, I have brevo.com. And when I go to this website, you can see n number of products over here. Notice this component is green in color. So this have a prefetching logic present over here. What prefetching means, I am fetching something in the background. So with this component, user may never interact with or never click on it. But what if user hovers over it? So whenever I hover over it, the particular component gets loaded in a background and it is stored in a browser cache until user clicks on it. So consider a sign up page. You are sure, which is a multi-step page, when you are sure the user will go to second page for sure. Whenever you hover over it, the second page gets loaded in the background and stored in your browser cache. Whenever user clicks on it, it's loaded instantly and user will feel as if the content was present over at the first load as well. So this is pretty cool. How it will look in a code. So yes, I have my use client since it's an island, and I have my pricing calculator. So pricing calculator is something which is, so for example, in the CTA section is pretty heavy. I don't want to load it initially, but I don't want to wait for user to click on it and then load it. So in this example, this island is not loaded initially, but I have a on mouse enter present over here. So whenever user hovers over a particular calculator, for example, in this case, this island is loaded in the background and stored in a browser cache. So whenever user clicks on it, I have an on click button to change the state and show this calculator. Whenever user clicks on it, it's loaded instantly and it feels as if the calculator was present in this page from the initial load at itself. So in demo, it will look something like this. So in this demo, I have a modal present over here. So in the initial load, you can notice I just hover over it. Mind you, I didn't click on it. I just hover over it. So it loaded the particular modal information or JavaScript on the network tab. and you can see all the data for the JavaScript, or all the data that is present on the modal is present in our preview. So whenever I click on this particular element, so the modal is loaded, and you can see now no extra JavaScript is loaded. So this is pretty cool when you are sure the user will open this modal or will go to the next page. So why this island matters? So this there is something called as the lighthouse performance, but there is also something as perceived performance. Whenever user visits a site, they want to see everything at an instant, right? They don't want to feel any lag in the website. So the perceived performance of this pattern is pretty cool. Island feels instant when it's shown. Secondly, it retains code splitting. So here in this example, I had my calculator present over here, but it's decoupled, or it's splitted into two parts, this whole CTA section. So it also retains the code splitting, and JS loads only when it's likely to be needed. Third, it's predictive UX. So it works great whenever user like hovers, scrolls, or for any idle preloading. So this is island that only hydrates if user needs it later for any heavy components or any pages. Now coming to our pitfalls and best practices. So yes, every coin has two sides. So for this architecture as well, there are something that people overdo. By overdo, they over island everything. So yes, over islanding is something, as the name suggests, having too many islands on your web application. So generally when I say islands, I want everyone to just keep this in mind. Don't make any atomic components as an island, only make molecular components as an island, because having atomic components like buttons or input box may cause too much JavaScript payload increase. So yes, increase the JavaScript, this increases the JavaScript payload, and it also bloats the hydration cost. Also, it adds unnecessary complexity to your web application. So in over islanding, I have an example present over here. So for example, in a form that you may see, there are input box and there are also button present over here. You are sure that user will interact with them, but you don't want to make everything as an island, because it will cause too much maintainability issue between developers, because if everything is island, it will get too much lost in our code, and readability also gets reduced. So better would be to make whole form or a molecular component as an island, rather than having a button or input box as an island. Second, I have like complex prop drilling. So by prop, we are sure like whenever three components share a particular state, it is known as like we can send them as a prop. But main problem arises when you have n number of island and they are sharing a prop. Suppose you are using pattern number 1 in prop 1 and pattern number 2 in prop 2. So having too many props sent to a particular component gets complicated, because few components you are loading on click, a few components you are loading on scroll. So it breaks the encapsulation, and it also creates tight coupling between few components, and this leads to hydration issues. So better would be to use any state or any context, rather than sending every data as a prop over here. So best practices are basically monitoring the bundle sizes. So whenever you create your application, you need to check if my JavaScript is increasing, or if I'm having too many islands on my pages. So you should check the bundle size of HTML should be more, rather than having too many JS related components. So set up automated alerts. Second would be use React DevTool profilers. So track the hydration timing. So whenever a page is getting hydrated, you can check what's the timing and how much time a particular page takes before getting rendered or before getting interactive. And third would be progressive enhancement. So start working with static HTML and then move towards our JavaScript. So start creating all think of it as creating everything on HTML, since it will reduce the bundle size as well. And third would be test without JavaScript. Since every person doesn't have, JS enable in our website, and our RSC are pretty static. So check per root size, like if every page is working without JavaScript or not, and you can introduce island as per your need. Lastly, I would like to discuss the impact that we have made at Brevo. So we have a pricing page which is too huge and was bloated with a lot of components like pricing calculator and cards. It has all the IP information. So this we applied islands to few components, and this resulted into 96 around score. So I have a we also use Metabase to calculate or to check the lighthouse score by monthly on our scale. So you can notice we started from around 70 and we reached up to the average of 91 score, which is pretty cool. Now, summing up what we have learned from our talk, or few key takeaways would be to hydrate only what's necessary. So main thing is whenever you start with island, you don't want to hydrate everything or over island something. So hydrate or apply JS to only those components that are necessary and not to everything. Second would be leverage island patterns. So yes, I have talked about islands. So you don't just want to dump all the islands or everything in a single view. You want to use patterns like lazy islands or interactive observer island that may be useful for your application. Third would be to measure and iterate. So when you start creating your application, just check per route, bundle size. What's the size of this, if the JS is increasing or if the JS is less for this page, and iterate according to your need. Third would be to avoid over engineering. So yes, when we learn about a new concept, we generally over engineer everything. We started applying islands to everything, right? But this results into proper, maintainability and readability issue. So just make sure don't apply islands to the atomic element, but just move ahead with the molecular element. And lastly, start small but scale smart. So thing is, we have learned about this topic and it may feel a little bit overwhelming to you. Like, okay, I have learned about this, which pattern to use. So start with a single or simple element or a component. So you can apply lazy island. And if you feel, okay, maybe intersection observer island will feel better here. So you can iterate accordingly. And lastly, yes, thank you so much for joining today. Hope you learned a lot. If you have any doubts regarding island architecture, you can connect with me on LinkedIn and on my X profile. Thank you so much.
Thank you, Navya. I especially, liked your analogy of a sea of static content, and in that we have islands of interactivity. I'm going to steal that from you. I'm going to use that to explain island architecture to my teammates.
Great.
Before we let you go, I just have one. I mean, we have time for only one question. So, are there any frameworks or tools that make implementing this architecture easier today?
Yeah, that's a really great question. So actually, Astro has an inbuilt island architecture. So my talk was majorly, inspired from Astro framework. They have inbuilt directive or props that you can send to implement this. I have presented my example with normal React application, but you can also add Astro or leverage Next.js to use this framework.
All right. Yeah. Okay. Thanks. Thanks, Neha.
Yeah.
I just blanked out. Thanks, Neha. And to our audience, please connect with her on Twitter and LinkedIn for more info about island architecture. Or I'm assuming you're also coming to Goa at the end of this month.
Yeah.
So you can catch up with her there as well.
Excited to meet everyone.
Thank you, Neha. Bye.
Bye.
Yeah. All right. Our next topic is about AI-assisted redux by Shruti Reddy Katula. Shruti contributes a lot to open source, and she's here to talk about redux. When I started working on React, we didn't have our Redux toolkit that time. We had the old Redux, and I used to be scared of it, man. Like, Redux Saga, Redux Thung, it was just too much. I used to always mess it up. So Shruti, are you like me as well? Is that why you came up with this AI assisted Redux?
Yes, I'm also same. Like when I started learning Redux and Redux toolkit, like it confused me a lot, like to remember all the things. So maybe that's why I came up with the solution.
All right. I'll let you take over from here. Everyone, Shruti Reddy Katula with AI assisted Redux.
Yeah. Hi everyone, I'm Shruti Reddy Katala. My topic is AI assisted Redux, leveraging the OpenAI for a smart state management, like smarter state, less weight, and OpenAI meets the Redux toolkit. Little about me is I'm a front end developer at QD42, where I have an experience on building a responsive and high performance web applications with React, Next.js, and GraphQL. And I'm also a active contributor to the open source, and I'm also a tech blogger. And today's agenda is like we'll say a quick overview of Redux toolkit, what are the disadvantages of traditional Redux, and what are the manual bottlenecks, why developers still feel the pain, and how we can integrate AI for the smart state management. And we'll look at a couple of examples like how we can generate the Redux slices using the AI, and also we'll see about how we can cache the cache using a RTK query and AI, and then we'll conclude the topic. Moving to the as all we know, like Redux is nothing but it's a predictable it is a predictable state container. It is a global state management library which is mainly used for JavaScript applications. It is not only tied with React, it can be used other JavaScript applications such as like Vue, Angular. And also it has a powerful dev tools like powerful dev tools where we can travel the debugging, like we can directly dispatch the actions, and we can look how the state is changing based on the actions dispatched. And also because of the centralized store, like we can like understand, update the state or the code in a much simpler way. The main core concepts of the Redux are nothing but like the first one is a store. As a name suggests, store stores the global state of the application. And the second thing is the actions. Actions are like plain JavaScript objects which describes what had happened in the application. The third is a reducers. Reducers are nothing but functions that specify how the state of the application changes in response to the actions. And also there are three core principles in the Redux. The first core principle is a single store, like everything, the global state of the application should be maintained at a single store, no multiple stores. And the second principle is, in order to like change the state from the application, we cannot directly interact with the we can't directly change the state of the application. In order to do that, like we need to dispatch an actions from our applications. The third thing is in order to all the state transitions should happen inside of pure functions, which are nothing but like pure reducers, which are free from side effects. So whenever JavaScript, whenever in order to update the state from the application, we need to dispatch an actions. Once the dispatched actions reaches the reducer, reducer takes the like current state and dispatched action. Based on it, it will return the updated state, and the updated state is being stored in the store. As the app JavaScript applications can subscribe to the store. Once applications are subscribed to the store, all the state changes are been like notified to the application, and it can like show the all the updated content in its application. So when we can where to use a Redux, like if there are multiple components accessing the same state, then we can we can use a Redux. And also when the state updates depends upon the like multiple actions or involve a complex transformations, then also we can go for the Redux. And also if there is a medium to large code base where multiple people are working on it, then also we can move to the Redux. Like what are the disadvantages of the Redux? The first thing is a boilerplate code. In order to we need to define the action types, action objects, and action creators, which are nothing but which return the action objects. And if there is a multiple state transitions, then we need to define all the state transitions inside a reducer with a switch state inside a switch statement, just to manage a simple state changes, this leading to the massive code volume. The second disadvantage of the Redux is nothing but dependency L. In order to do something useful in the Redux, we need to install a lot of external packages like Redux Thunk or Redux dev tools. So these are the few disadvantages of the Redux, which made it way to the Redux toolkit. What is Redux toolkit? Is a modern solution where Redux toolkit is an official and recommended way to to write a Redux logic. Why Redux toolkit is been used? Because what are the advantages of a Redux toolkit over the Redux is less boilerplate code than the traditional Redux. There is no need to write all the manually write all the action types, action creators, and switch cases inside a reducer. Simple, the create slice function solves the issue. The second thing is built-in tools like Redux Thunk, Immer, or DevTools extension support, which are pre-configured and ready to use. We don't manually need to install these tools. And also it also includes a powerful RTK query. RTK query is nothing but it is a powerful data fetching and caching tool built in the Redux toolkit, mainly designed to simplify the data loading in the React applications. It eliminates the need to write all the repetitive asynchronous data fetching and caching logic manually by automating these processes. Some of the key features of the RTK query are it helps we can define the API endpoints ahead of the time in the create API function. And also we can use a fetch based query, which is a simple wrapper around our fetch for standard requests. And also we can automatically generate the React hooks for the each endpoint to fetch data and manage the handle the loading or error states. And also we can manually cache and automatic the cache invalidation. And also it fetches the data in the background synchronously for the optimistic updates. And also it provides it also supports a mutation for a create, update, or delete the data for with optimistic updates. And also it provides life cycle options for cache entries like refetch on the browser focus or when the user reconnects. And also it helps to reduce lot of boilerplate code while improving app performance and consistency. Consistent. Still, there are manual bottlenecks where the developers still feel the pain. The first bottleneck is boilerplate code. The developer has to write a repetitive slices for the standard CRUD operations. And also developer has to manually map and define every state transition. And also with the caching, if the fixed invalidation tags either lead to the overfetching or stale data. In case of overfetching, when the cache invalidation tags are too broad or rigid, RTK query may either refetch the data more often than necessary. This results in redundant network requests. It also increases the network latency. And also it also increases the server load, thus degrading the overall app performance. Regarding the stale data, if the invalidation tags are do not properly cover all all the dependent queries, like some parts of the UI may continue to display the same outdated data until the manual refresh or a component remount, leading to the like inconsistency or a stale data, which is not a good user experience. So, what's the fix for all this? By integrating a AI in our state management, AI, by integrating a AI, like we can auto generate the create slices code from our natural language, eliminating all the boilerplate code, and also AI also can predict the also can watch the user behavior based on the user behavior, how frequently he's accessing a particular data. Then based on the AI prediction, like we can prefetch some of the queries, which increases the faster load time. And also as we saw previously, like overfetching or a stale data based on the invalidate tags, like AI can also analyze this mutation to determine the precisely the RTK query tag invalidations, avoiding the like overfetching or a stale data issue. I'll show a small prompt where we can generate the redux slices using OpenAI. Like firstly, I want to have a notification slice where where the redux slice a named notification stores the list of notifications where it has a message unique ID and a boolean flag which tells whether the notification is read or not. And I want to create a reducer mark read which sets the is read to true for a particular given notification. And also I wanted to include an extra reducer to fetch the notifications from an external API. And then when the API call is successful, I want to set the existing notification. I want to clear all the existing notifications and add the new fetched notifications. This is a prompt I'm going to give it to the AI. This is a AI output where it created a slice, and I wanted to create an extra reducer to fetch the notifications. It automatically created the sync, create a sync thunk, and it fetched the notifications based on it. It even created the reducers, extra reducers, and it is doing all the stuff. This is how AI generated output allows us like developers to skip writing all the boilerplate code by automating a repetitive processes, saving time and letting us to focus on the real issues. The second thing is, as we already discussed, like RTK query, if with a fixed invalidation tags, like either we are leading to the overfetching or stale data. Here we can solve the issue using an AI, where we can capture the mutation type, user data, how frequently is interacting with a particular query or something, particular data. And also we can tell the affected entity context. Based on that, LLM determines the minimal required set of invalidation tags. And we can by returned invalidation task, we can deliver the faster UI with a few necessary network requests. Thus we can avoid all the unnecessary network requests and everything. I'm giving a user prompt as I'm giving the user prompt with all the necessary data like mutation type, payload, and if the payload is a critical, what I'll do is I'll ask for the broader cache refresh. If the payload is like not critical, I'll ask for the standard and requires minimal refresh. And I'll also provide a user behavior, how frequently he's interacting with a particular data. And also I'll give the all the available tags, all the available tag types available in our RTK query. And I'm asking the AI to provide a JSON array containing the exact RTK query tags that must be evaluated, to ensure the cache coherence while minimizing the unnecessary refetches. The system prompt would be you are an expert cache invalidation decision maker for a RTK query. And I'm also telling the system to provide a precise raw JSON of the RTK query based on the provided context above, and the array must contain only these tags. I'm giving this to an AI, and based on that, I'm defining my RTK query with a create API function. I'm defining my endpoint. I'm defining my endpoint here, and and I'm defining my endpoint create post, where it creates a post. And on query started, in the RTK query, on query started is a optional lifecycle callback, where you can define endpoint to run a side effects when the query or a mutation starts. It's particularly useful for optimistic updates, logging or performing the additional async task before or after the request. Based on that, I'm calling I'm calling an API call, but I'm providing with all the my mutation type data as a payload, and all the user behavior, what all required for the API call. Once the API call return once the API call OpenAI call returns the tags, I'm dispatching it I'm dispatching the invalidation to only those AI determined tags. Uh, yeah. With this, we came to an end. With this, a React cache process can be automated, reducing the manual work or improving the efficiency. Efficiency. And this brings us to the end of the session today. The closing insights are. The future is automated. AI powered Redux transforms the state management from manual efforts to autonomous intelligence, saving a developer time while supercharging the app performance. The key highlights of this session are how we can generate the slice. AI automatically generates the create slice code from our natural language, eliminating a boilerplate code for the standard CRUD operations. And also it intelligent caching, context aware caching invalidation, ensures the precise updates, preventing the stale data or overfetching. And also AI anticipates the data needs based on the user behavior and the app state, enabling the prefetching for faster perceived load times. This way, yeah. Thank you everyone. This is my LinkedIn QR code. We can stay connected and there. And if you have any doubts, you can ping me on LinkedIn as well.
Thank you, Shruti, for that very informative and insightful talk on AI-assisted Redux. Before we let you go, have you experimented with this approach with other state management applications like MobX or Redux context, React context?
No. I started with the Redux.
Okay.
I'll explore it.
Okay, maybe something for the next next
Maybe,
talk.
yeah.
Okay. Thanks once again, Shruti. And yes, please connect with her on LinkedIn to know more about AI-assisted Redux and about other things that QED42 has been doing. Okay. Thank you.
Thank you.
All right. Last talk of the day. Thank you, everyone. I want to preemptively thank everyone who have been here with us from the first talk. And I've been looking at the YouTube chat. Some people are wondering, are there any giveaways, for your dedication for today's remote day? And yes, we will be giving free conference tickets through a lucky draw. Whoever have registered, we'll be picking a lucky email and we will reach out to them with a free conference only ticket. No stay involved. Okay. Yeah, I mentioned that now so that people don't just disappear thinking, oh, we have already registered and we don't have to attend. So haha, I tricked you guys. Anyways, our last talk of the day, we have Aprajita Verma here with us. She's going to talk about self-evolving forms in React. Aprajita is a front-end architect with 16 years of experience. Wow, 16. Damn. I don't know what to say about that. Outside of work, she enjoys traveling and trying on new cuisines. Aprajita, where have you traveled recently? You're on mute, Aprajita.
Am I audible now?
Yeah.
Yeah, I just finished my 15th country in April. I did Vietnam.
Oh, okay.
Really cool. Yeah.
Cool. All right, Aprajita, I'll let you take over from here. Bye.
Sure. And before I start, thanks Rajat for making me feel a little old by saying 16 years, but that's good. It gives me a context. So
you don't look that old. That's why I was so shocked.
Thank you. But on that very good note, I will start. So my topic today is self-evolving form in React, and what an amazing day it has been. We had so many talks related to React. I hope my screen is visible to you guys. I am not sure.
Yeah, it's visible.
Cool. So my talk is about again AI, but I'm going to discuss a little more about the UX part of it instead of just the AI part of it. And this is my agenda. And as you know, you should always know what is coming in advance. So I will give you the context of why this talk was needed at this point of time. I will try to explain you what is the difference between the static and dynamic schema that has been referred in my talk. I will try to explain what are AI-driven schema. We are going to talk a lot about UX law, and it's not to overwhelm you, but to give you a context about you, that even if you are a UI developer, you should be aware about this UX law, and especially when now we are developing our UI with AI, it is very important for us to have some guardrails. And finally, I always finish my session with a quiz and some Q&A if you want to. As Rajat said that there would be some giveaways, but these quiz are just to check that you are not sleeping. Now, just like any other saga or nightmare, I will give you a little bit of context that why I think that this is such a game changer, that now we have dynamic schemas, that we can have a form which is self-evolving. So as I have been working for 16 years in UI development, and we literally started with, I don't know if you have heard of it or not, applet and swings and and then we were doing JSP, servlet, and JSF. People keep on talking about server-side rendering. It's like such a big thing, but I started the job when everything was getting rendered at the server side, and from that we are now in a stage where we are talking about AI, which has just flooded to market in last 2 years. So in this journey, there has been multiple instances when I'm talking to some CXO or some board members, and where I sometimes feel like what do you want? Do you want me to generate the UI? Whatever you are thinking, I don't even know what you're thinking. You are not telling me, and you want it to happen. And somehow it is coming to be true that whatever we are thinking probably can be translated into the UI through this magic of conversational, interface that we are creating. But conversational interfaces are not something which is new. It has always been there. We have been creating chatbots or faking to create chatbots, if you remember. So it's always has been there. And there is one thing, the one OG which has always been with the UI development is the forms, right? That is the reason why I picked forms, that not only other areas, but also forms can be evolved with AI. Now, the topic of this topic is of this talk is very simple. What we are going to do is try to create a system where whatever you think can be converted into a form. That's it. That's pretty much it. Now, after this small story about my, Now, so the context that I wanted to set here is that the traditional forms that we create in any framework or any language or any library, they are static and rule driven. What happens is that the user adapt to interfaces instead of the interface adapting to the user. But the next frontier that we are going to discuss here is a cognitive UX, a UX that can think, that a form that can understand, infer, and evolve. And how do we do that? By a combination of React or LLM, which is making it kind of achievable today. But what we are doing here is making sure that the guardrails are there. So when I was defining this, and I was like, wow, this is happening. But I was also like this, oh, this could be a hallucination. This could be a problem. So I will try to show you that as well. From the diagram, I hope you are able to see in static form, we just have some fields which are predetermined. Whereas when we talk about an adaptive form, a user provide an input, and then based upon the user input, you can have different kind of forms. You can specify that, oh, this is my design system, these are my components, and AI get to decide that what are the form elements which will be available to the user. Now, I have listed down some UX law here, and this is not at all to intimidate you, because I switched from only UI developer to UI plus UX only after 8 years in my career. So, but now I do understand these laws, and even if you do not have in-depth understanding, a slight knowledge of this will always help you to become a better UI developer. Not a designer, but at least while you are developing, you can understand, oh, why the hell my designer keep on telling me that you cannot have a drop down with 52 elements inside it. There is a reason behind it, because as per Miller law, your brain can have only a choice limit between 7 plus minus 2. If you exceed that, then in that case, your brain will not be able to comprehend it. So these are some of the UX law which are very relevant when it comes to creation of a form. So this is true for a static form, and in the end, we will revisit this again to see that how it is true also for a AI adaptive form. Now, when I talk about a static schema and a dynamic schema, it's pretty simple. When we say a static schema, we have the field definition, which is hard-coded, whereas in a dynamic schema, the field definition is generated by the AI. Of course, when I will show you the demo, and inside that demo, I not only wrote prompt, but I also write many sub prompts also to make sure that the dynamic schema is getting generated. When we do a static schema, it is fixed. It cannot be adapted. Whereas a dynamic schema can evolve with user input. It can be actually recursive. So you have provided some input, some form elements are generated for you. If you want to adapt it further, you can still ask AI, and it can generate more form element for you. Maintenance for a static schema is manual update, whereas for dynamic schema, you kind of just define your design system once to the LLM, and then after that, it will be able to do a self-update of it. The user experience for a static schema is one size fit all, whereas for dynamic schema, you will see that it is very context aware and it is personalized in nature. Now, before I rant further, let me show you the demo so that maybe you will be able to it might just click to you what I'm referring here. So, one more sidetrack. When I was doing this demo, the first choice that I took was for a medical form, and then I was like, no, that's the wrong choice. I should not be doing it because it was giving so many wrong information. I mean, why do you ask me that if I'm having a pain in my toe and you are predicting that, oh, I might be having heart attack? So I switched to a simpler domain, which is a form for job application. Aren't we all filling it every day? So this probably everybody would be able to relate. So suppose when we refer to a self-evolving form, suppose that you have provided few options here. This is a very important UX guardrail that for the AI, you have to provide options. You cannot expect every layman to define the prompt or the query what an AI is expecting. So what I did, I just added few options here. And when I click on any of these, the form elements that are getting generated here are dynamic based upon what is the role that I have selected. The AI is able to identify, oh, we are referring to tech lead. So if somebody is a tech lead, then probably I should ask these questions so that they can answer them and then they can go further. Now, one very important point here is that, again, a UX guardrail, that if you see here, I am also providing some form insight. Now, these are very important because we know that AI output depend upon what is the model that you are using. It depend upon what is the temperature that you have calibrated. So it is very important that at least at this point of time, I can't predict it after 2 years. It could be AI could start giving everything completely accurate. But at this point of time, you do have to notify to user that you know what, some of these are generated by AI. This is a possibility of accuracy of it, so that user can also understand that, oh, it's not like that this is perfect. And it could be a possibility that I can ask to analyze and evolve this form further. Now, as I said that for tech lead, there are some form. If I do for data scientist, hopefully it should work. Yeah, some other form should be generated. So instead of having a static form, like for example, I had it here. So, when you fill a form for a job application or anywhere, you kind of add your experiences and everything. In the same manner, here also, the self-evolving form, you will just provide some information and AI is generating those forms for you. Now, let's go back here. So this, I hope, is clear to you all. Now, when I'm referring to this dynamic type of schema, what I'm actually saying is that the React is still rendering the components. So the components that are required for generating that kind of form are still in hand of React. When we talk about user interfaces and type of inputs that you can have, they are limited. It's not like that one fine day there could be a completely different type of user interaction that you can introduce. Till the time we have a two-dimensional laptop or a screen in front of us, I do not know in the future if we are doing what we are doing in a virtual reality. But so far, you can have a input box, a text field, you can have a radio button, you can have a grid, you can have a drop down. So they are limited. So React take care of rendering of these components, whereas LLM renders the context. So LLM let you know based upon what input that you have provided. LLM decides the context and it's provided to React, and then React would be able to render them. So I hope this is clear that what we are trying to do here is to infer some field, validate them, label them, add some dependencies. And then the schema inference flow would be like this. The user interact with the AI service, which is a schema engine, and then the UI evolves on that. Few key features of React that I have used for doing this demo is suspense, use transition, and yeah, definitely a lot of React hook also for making sure that the dynamic state is managed. I am going to quickly show you just a small bit of my code, and I will be sharing this code to GitHub, and I hope that Rajat will find a way through which we can share with you guys. So if you can see here, of course, I do use AI. I mean, like, come on. So if you can see here, the most important, and this is the simplest example that I can come up with. If you can see here, The most important file for me, apart from the AI services, is the types that we have defined. So I have defined that there are some static fields, but I have also defined that there are some dynamic fields. And the AI prompt, through AI prompt response, we get to decide that from this dynamic field, which all fields are going to be rendered to the user based upon their user input. Now, if I go back here again, let's do a little bit of more demo. Let's do a little bit of more demo. And if I come here, this one is this one is not actually self-evolving form, but this is a simple smart form demo which will help me to explain to you that what are the UX guardrails that you have to consider. Now, this is an example wherein a user has to enter some data for related to their employment, and like all of us are doing, conversational UI. So you type something inside it, and then you want to parse it with AI, and then after that you will be able to, maybe fill the form, maybe generate some more fields inside it. Now, there are few usability check marks that you should do to make sure that this is stable. So first thing that you might have seen that I have already provided an example. You must be seeing it in most of your AI related tools, that they definitely some starting point is provided to you. Apart from that, there are some options here as well. So like, for example, if I put it here, and now what it has started to do dynamically was it was trying to parse it with AI. So it just sends a call to my LLM and parse it and show me what is the result for it. Now, see, one very important point that you should also consider is that it was able to parse it, but it did not directly apply to the form. The human in loop is very important at this point of time. So you see the parse result, and if you are happy with it, because I have a voice input here, and I have tried to do this prompt many a time, and most of the time it cannot even understand my name. So this is important that before you are applying to form, you first of all parse, you see what is the AI parse result. If you are happy with it, then you go and apply the form, and it is simply going to apply the form for you. Now, there is one also very important pointer that I wanted to show you is the AI confidence. At any point of time, you have to. So I did a small algorithm based upon how many fields it was able to identify based upon how many data points it is accurately able to identify. Based upon a simple algorithm, I am trying to show that what is my confidence with respect to the AI response which is getting generated. Now, let's go back here. Now, let's talk about the UX guardrails. We just saw the UX laws before, and I just wanted to go through these one by one. And it's okay if you are not aware of it. I would really suggest to have a quick look about it. When you are defining your AI-generated form, when we define our static form, then in that case, we always take care of this. Your designers are taking care of it. Now, when you are getting it generated by AI, you have to make sure that these guardrails are taken care of. The first one is the Hicks law. At any point of time, there should be only a certain number of options that should be present. If you increase the number of options, the response time of a user decreases. And there is another UX law called the Dorothy threshold, which says that a user and a system should interact with each other by a time of 400 milliseconds, then they are optimal. The second is the Miller's law. I had this experience where I asked somebody to generate a small feature, and they came up with, they used AI, and it came up with a drop down with 72 elements inside it. So AI did not care about it, but we have to care about the Miller's law, that at any point of time, you have 7 plus minus 2 items in your memory. So you have to make sure that the elements are restricted. You have to make sure that your form is also evolving progressively. Do not show 32 fields all at once. The third one is the Jacob's law. That means that even if I'm creating a static UI or a AI-driven UI, it has to look similar. As I mentioned that there is certain way through which you can provide an user input. We are not inventing something new here. So please make sure that even the adaptive form looks familiar to what you have. The static form, like the design system, looks familiar. Then is the Fitts law. Fitts law says that as you increase the distance between two items, the chances of to be able to interact with them decreases logarithmically. So please make sure that that is also taken care of. And then there is a gestalt, which is law of continuity, that dynamic UI changes must flow naturally. So do not have an sudden context shift. Do not generate 20 forms elements without checking, without adding any check inside your code. Also one very important thing which is in my code is that while I was doing this, preparing this demo, I ended up using up all my tokens. And then I was like, oh my God, I have to do the demo. What would I do? And I realized one very important point that I have to do whenever I'm using AI for such kind of user experience is always have a backup. That means that if I'm not able to get an exact response from AI, most likely I would have to also rely on some mock data or a JSON, which will at least unblock me and proceed further. So when I'll be sharing this, demo with you, you will see that throughout my code there are a lot of mock data. I needed that because if I do not do it in the demo, if it is stopped working, I have no other way but to just say that, oh, demo effect. Now, the conceptual summary of whatever I have shared today, and I see that there are a lot of comments in YouTube. I have it next to me, so I will be discussing it with you. I love it when there are so many discussion. The important thing is that the line between design and intelligence is blurring, but the UX law remains the same. Till the time we are creating our applications for user, we have to take care of usability laws. Now, in one of my previous talks, somebody actually asked me, what about the time when machine will be creating applications for the machine? And I was like, I don't know, we will see what we will do. But for the time being, since till the time we are creating it for the human, we have to make sure that the usability laws are taken care of. AI and React enable self-evolving front ends very efficiently. React act as what you can say a pedestal through which we can do it quite easily. The concepts in React actually allow it to do it in a very easier and efficient manner, very performant manner as well. The future design system will learn from user behavior, know this thing. So again, a sidetrack. Recently, I was taking an interview and somebody, when I challenged them about a question, they said that it is generated by AI. The answer is generated by AI. And when I said that, no, this is wrong, they had the look on their face saying that you think you are smarter than AI. And then I had to tell him that, you know what, I've been coding for 16 years and before that 4 years in my engineering. Some of these models are trained on my bad code only. So maybe in certain cases, I'm responsible for the bad response that your AI is generating. So yes, it is a possibility that AI can give wrong response. The design system is completely learning from our user behavior or our patterns. The React remains the canvas and AI becomes the co-designer here. Now, as I mentioned, there would be a final quiz here. And I hope that I'll be getting some answers on by you guys. There are no definite answers for this, but I hope that you will be able to at least guess what is the correct answer. So suppose the example that I give in the same manner, when your AI-driven form adds favorite dinosaur after detecting the word engineer, what's the correct UX response that you will do? Option A is that you are going to embrace the chaos. Clearly, the AI knows your Jurassic skill set. The second option is that you will apply Hicks law, fewer raptors, fewer decision. And the third is that you will recheck the schema inference accuracy before it eats your data. So the kind of correct answer would be is that always validate the AI output before applying. Cognitive UX is not cognitive guesswork. You will end up eating all the tokens. So do not do that. The second question that I would wanted to ask was that your self-evolving form suddenly shows 14 new fields at once. Which UX law just screamed in pain? The first is Miller's law, because human can handle 7 plus 2, not 7 into 2. The second is Fitts law. Those buttons are not galaxies apart. The third is Murphy's law. When the things go wrong, it just goes wrong because your PM just saw it live. Now, the answer would be the cognitive overload breaks adaptive magic, evolve progressively. So when you are defining your dynamic forms, please make sure that you evolve progressively. Do not generate hundreds of forms in one go and show it to user. Now, the third question is your AI-driven dynamic form keeps regenerating the schema on every key stroke. What's really happening here? The LLM is just vibing just like we are vibing with your typing speed. So you type and it's just, two more form for you. Or you accidentally made a use effect depend upon form data and now React's doing CrossFit. So I hope you all knows that you have to be very careful about, use effect. It re-renders things. So, or it's not a bug. It's a real-time adaptability. It's a trademark that I'm saying. It's just creating it, probably it's fine. The correct answer would be, because in the land of dynamic schema, when we are talking about dynamic schema, one misplaced dependency can turn intelligence into infinite loop. And with this thought, I want to mention this thing that this is a possibility. This is the future. And as us UI developers, we are going to do it very soon. But please be very careful when that you are not breaking the UX law. You are not deviating from the correct coding pattern. AI can generate a lot of things for you, but you are human in the loop. So always make sure that everything is checked. Now, this is pretty much from my side. This is my LinkedIn. And if anybody wants to connect with me, and as I mentioned that I will try to check with Rajat that how can I share the PPT with you guys or the demo with you. Thank you so much for your patience listening.
Thank you once again, Aprajita, for that really great talk. So my question is that, do you think we are ready to implement this in a real world production ready application, or are we still in a prototype phase?
Loaded question, Rajat. Wait for it. Try it for sure. See how frequently it is failing. But the way AI is evolving, we might end up in a situation that this becomes truth. So try it. As of now, I will not say that if you do not put the UX guardrail, do not put it in production. Make sure that you check, recheck, and recheck it again. Yeah.
Sure. All right, Aprajita, thank you. And regarding sharing your code and slides, I would suggest the best way would be like if you share it from your side on your social media handles, maybe.
Perfect. Yeah. Will do. Perfect. Thank you, Rajat.
Yeah. All right, we are done for the day. How does it feel, everyone? I'm pretty tired, but I learned a lot. For conclusion, I would like to invite my co-MC, who unfortunately couldn't make it today throughout the day, but manager didn't let her. Sad. Sakshi, tech team, can you please add Sakshi to the screen?
Yeah. Hi everyone, I'm Sakshi and thank you so much Rajat for taking over it. Yeah, I am here to say huge thank you to all of everyone on the behalf of React India team. A big thank you to everyone who made this possible. Our amazing speakers for sharing, giving your time and sharing so awesome insights, and wonderful audience. I know it was an office day, even though it was a busy day. You guys stayed tuned till now. It's awesome to see the energy. And our amazing sponsors, platinum sponsor AWS, gold sponsor Brevo, Firebase, Disha & Co, and our silver sponsor Talentship and Arcesium. Yeah, that's pretty much about it. Thank you so much, everyone. And the online edition has been awesome. And as you guys know, there is an in-person conference at Goa. And yeah, Rajat will inform you about the same. Yeah, Rajat, please, if you can guide everyone about the React conference in Goa.
Yeah, so as I said at the beginning of this day, remote day is like a appetizer or a teaser trailer for the main conference that is happening at the end of this month. We have a workshop day on 30th October. We have great workshops from AWS and other people as well. Saurabh Dhavari is going to give a workshop about vibe coding. We have a workshop from Brevo as well. So please do buy buy the tickets for that. You don't want to miss it, if you want to stay in the loop about AI and React. Also, our main conference that will be on 31st October and 1st November. We have some really great talks from some very well-known speakers and some newcomers as well. But they are well curated, and I'm really excited to see all these talks. And to all our audience members here, I would say again that we are going to give free tickets to some lucky people. We'll reach out to them soon, and others also. Please try to make it. This is the 6th time we are doing, and your encouragement, your being there and seeing you guys learn and interact and socialize with our other audience members and our speakers, that is what drives us. So please do make it there. Please reach out to me as well. We'll try to party if we can. Yeah, I'll see you guys all there, and thank you once again for joining us for React India Remote Day. All right, thank you. Bye.
Yeah, thank you, everyone. Thank you so much.
AI is changing the game for app development. Firebase is here to help. We offer a platform designed to support you throughout your app and business's journey, so you can rapidly build, release, monitor, and optimize apps with Google's latest AI technology. Easily build AI-powered experiences into your apps with speed and safety. Then, launch, monitor, and iterate with AI tools that help you optimize your app's quality and experience. All with assistance provided by Gemini, Google's largest and most capable AI model, helping you to work faster and smarter. Firebase helps you run your app with confidence, deliver the best experience for your users, and get to market quickly and securely, doing what you love. Make your app the best it can be with Firebase.
React India.
React. React India. React. React India. React.